MTech from Indian Institute of Technology, Kanpur. Ma'am, research areas include development of advanced air, water, and wastewater treatment technology and environmental modeling. Her publication include more than 8 book chapters, 2 patent, 1 license, more than 200 articles with an H index of 47 and I-10 index 110. Ma'am has a citation of more than 7,800 citation. She has been an executive member of Environmental Division of the Chemical Institute of Canada, organizing chair of Environmental Symposium of both CIC and Canadian Society of Chemical Engineers, guest editor of special issues of International Journal of Chemical Reactor Engineering, Environment and Energies. Ma'am has also received various awards like the Western Engineering Excellence Award, Hillard Distinguished Speaker Award of Institution of Chemical Engineers, Vanguard Awards, Vanguard Awards, and the her research expertise is on the developing advanced treatment technology for waste stream based on physicochemical processes, environmental modeling based on computational fluid dynamics, and fate process based transport modeling. With this, I invite ma'am for her lecture with huge round of applause. Ma'am, please, you can start.
Hello. I think if Mr. Mati, if you can switch off your mic because I can hear you. So, is everybody? Am I audible?
Yes, ma'am, you are audible.
Okay. Thank you. But I cannot see you. I cannot see anybody. So, how many people are there?
Ma'am, we are here. More than 50, 60 participants are here.
Okay. And unfortunately, I cannot see any of you. And unfortunately, that generally I do go to India in this time, in the end of year. But this year, due to some personal reason, we could not be in person in India. So it's my real pleasure that when Anupam actually asked me to give this presentation, so it's not really my research area that is one of the peripheral area. I work mostly on the water and wastewater treatment, industrial effluent treatment. But lately, as a director of the water center at Western, I'm also doing some resource recovery type of work. So this felt like this work would be um, better suited for the theme of your conference. So I'm going to talk about the synthesis and characterization of biodegradable craft lignin-based hydrophilic phenol formaldehyde foams. The work was done in collaboration with Dr. Prakash, A. Prakash, and Charles Shu, and the PhD student is this Glenn D'Souza. And so, just to give a few little background on how the Western University, where it is located, it is actually at the southern southwestern Ontario and bordering Detroit, that Michigan of United States. So this is a complete university. Actually, Anupam spent almost a year with me, and so it's like about 35,000 students. And so this is the campus. It's actually quite pretty during the fall and spring. So with that, and that's my building where we are located side by side several engineering buildings. So that's called Thompson Engineering Building where I sit. So with that background, and I want to introduce you to this talk. So I'm going to talk about these phenol formaldehyde, the foams that are produced from phenol formaldehyde resin, and the applications are generally in a lot of different applications, but the one that we are trying to target is that. Do you see a flicker in my computer? Are you seeing any
No. No, madam, no.
Okay. So then the application is mostly in that the application that we are trying to do for this type of foams is for the floral industry,
Side hook.
where the for floral arrangement you need hydrophilic foam which can absorb a lot of moisture so that the flowers are fresh at least for a couple of weeks, and then also for sound insulation. And so the thing is that traditionally these foams are produced from the phenol that is produced from petroleum products, petroleum resources, but it is also doing in petroleum resources as well as more carbon dioxide emission, that people are looking more into the bio-based product. So we are trying to use bio-based product like agricultural
नहीं
waste,
आएगा सर.
and in this case is
ठीक
actually
है.
इधर
coming
वाला
from pulp and
चेक
paper
कर लो.
mill, the craft lignin, that would be the source for production of
अभी
phenol,
रहने दीजिए सर.
and that would go into making the resin. So then, so it's basically the lignocellulosic biomass, any lignocellulosic biomass can be used, which were the good source of phenol, alcohol, and organic acids. And so, with that, in this particular project, we are going to use two types of. Actually, my title talks about craft lignin, but we also use sulfonate from the pulp and paper mill. So, is that okay? Can you hear and see me? Okay.
Yes, ma'am. Yes, ma'am.
So lignin comprise of phenyl propane units that can be degraded to form biophenol. One of the objectives also used to use this biophenol so that the foam that is being produced can be biodegraded, because currently the foam that is coming from phenol are just put at the end of the use they are just disposed of in landfill, and that takes effort to degrade those compounds. And so that's one of the objectives, that we want to see how this at the end of the life, how these foams are biodegradable. So just to give you another pictorial view of this, that conventional approach, you have that the phenol is coming from this older petroleum fraction, and then with the formaldehyde it forms a resin, and then it goes to the foaming process, and that's what these are like solid blocks of foam that are used for insulation as well as for hydroponic application and flower arrangement. So in our work, we are going to use lignocellulosic biomass to get biophenol, and that is going to produce this biophenol foam, and then we are going to today I'm going to show you two different application of it. It is for the seed germination in hydroponics as well as dye removal from wastewater. That's the objective, that instead of phenol coming from petroleum by the cubing process, it's actually that acid wash craft lignin. So we use both as it is lignin or depolymerized craft lignin to obtain this a foamable bio-based PF resin, PF meaning that phenol formaldehyde resin. And so we'll be looking into the influence of this craft lignin substitution on the weighting property, because as I mentioned, this is good for the floral application. So the how these foams are weighted, their weighting property, and then mechanical strength, and also the morphology. Like open cell that would be carrying a lot more water. So then also at the end, we also tested the biodegradation of these foams using control studies, and also looked at some of the biodegradation pathways. So just to give you how this foaming is done. So basically first we produce PF resin. For most of this phenol formaldehyde resin, we actually used these are PO phenol to formaldehyde ratio is greater than 1, several different ratios, and then it is in basic condition which produce dissolves. So then these resins are basic resin, so PF resin, and then we added different types of surfactant and weighting agent and blowing agent like cyclopentan or pentan, hexan, different types of blowing agents. So the first this process was optimized, like what should be the type of surfactant that would give us the best foam characteristics. So that has been one of the beginning, at the beginning, that's what we have tried to optimize this process. And it goes to high speed mechanical mixing for about 30 to 60 seconds. And then it's, foam curing catalyst, which is typically some acid, inorganic or organic acids are applied. And then it goes to, you can see that the foam is formed, which is cured at 60 to 80 degrees Celsius for 1 hour, and then you get the PA foam. And so when instead of phenol, if we just use the craft lignin, so we use two types of craft lignin, by craft lignin by itself or depolymerized also. So this is then you are adding the craft lignin with the PF resin, the phenol formaldehyde. So we get the resin first, and then again curing acid, the surfactant are added. So this would be actually help to produce a foam in the resin, and then these are the blowing agent that actually the either hexane or penton that creates the void in the foam, and then it gets cured at 70 degrees Celsius for an hour, and so that would give rise to the foam. Now, how these foams actually absorb water is basically you have the surfactant like sodium rhodecyl sulfate, and so then it is basically the hydrophilic portion of the surfactant actually attracts water molecules, and then it goes to the pore by capillary action, and that's how the pore of the foams is filled with water, and that can serve as a for when the flower arrangement is done. This is the source of water for the flower arrangement. So this is just to show you, we have done, as I said, a lot of optimization had gone in initially to get the best quality foam. So this is just to give a snapshot, like if I just use the pure phenol formaldehyde resin, there is no lignin substitution, and this is a typical recipe. As I mentioned, it is alkaline, the result type of resin, so that's why sodium hydroxide is added. And then instead of phenol, we just use the craft lignin, so then up to 50% substitution was looked at, and then we look at the density of the foam and the open cells and the water absorption capacity. These are the things are measured along with some chemical characterization. So so then once the foam is produced, it needs to be neutralized because, as I mentioned, it is basic resin. So then its acid neutralization happens, and then I cannot see it. Yeah. So then yeah. So this is how the for different phenol formaldehyde, formaldehyde to phenol ratio. It's important, as you can see, that if for a certain F over P ratio, we generally don't get any foam. So this would be one of the better F over P ratio of 1.8 that just get a better foam. And then here we different types of blowing agent. Blowing agent basically makes the pores within the foam, and so this is cyclohexane. So I think PF1 is, let me see. So PF1 is basically cyclopentane, was used as a glowing agent, and PF2 and 3 where we had used hexane of different percentage, and PF6 is, so we have only up to PF4 here, but yeah, okay. So this is basically different um, glowing agent, and you don't want to have too much pore, like it is too porous, then it will break. So you have to have a right condition of compression, the mechanical strength as well as porosity. So this is again the effect of different curing catalysts. As I mentioned, the curing catalysts are generally inorganic or organic acids. So in this case, the PF6 was acid catalyst used at 21%. So typically the acid catalyst, inorganic acid, sulfuric acid tends to work better. And so then these are the different composition or weight percentage of acid catalyst that was used. And so in this regard, I think PF 7 and PF 8 performed better in terms of mechanical strength. So then we also look at the scanning electron microscope picture to see which are the better foams. So this would be one example. So on the left you see the commercial PA foam, which is Oasis floral foam that most of the flower industry uses. So this is commercial foam, and so our foam somewhere comes. One of the better foams would be this one, the C with the weighting agent PF1. I think this is probably one of the chlorothiol sulfate or surfactant 2 in 4060, that those type of surfactants were used. And then we also do a lot of characterization of the different types of what are the groups that by looking at the APR spectra. But I don't want to bore you with many of these type of spectra, but just want to show that we want to make sure that the formulation that we're getting is corresponds to the compounds that we're putting into the mixture. Then we also add different types of additives. So one of the additives that these are basically to retain more water. So PF24, that adding calcium carbonate was one of the better additive materials. So we can see that. So we would like to have a lighter density of the foam so that they're easy to transport, and so then this gives us a least density of 50 kg per meter cube, and open cell content is about 72. That means the porosity, the open cell, and the water absorption capacity. This is one of the higher one, like 1500% water capacity. And the extreme right number is that the water uh, retention time. Like how fast it water uptake rate. So then now this is just to show you how the different percentage of craft lignin content, how the foam density is an important parameter because you want to have a light density, but it's not too light so that the mechanical strength is uh, compromised. So then you can see that with different, this is a good range of foam density for floral application. So we could just go up to 30% of lignin content, and this is also important because when we do the biodegradation study, we need to see at what lignin content we get the best biodegradation of the foam. So then here on the right hand side, you can see that with the lignin content, how the water absorption capacity first increases, but then it reaches a plateau, and then the water uptake rate also is increases with the lignin content. And so this is how the influence of craft lignin on how the foam morphology changes. This is with the ACM pictures that you're seeing, that this is the first one if there is no, this is just basically commercial phenol is used for the foam production. And with the craft lignin substitution, we can see that foam characteristics does not change drastically. So up to, this would be the range that we'll be looking at. 20 to 30% craft lignin would give us the foam of desired characteristics. So then now we know that these foams are good for the application that we're looking at, but now we also want to see their biodegradation. So this is done by incubating these foams with the bacillus species that with that incubate. This is after 15 days of incubation. So typically we can see that when it is commercial, that there is no the phenol coming from petroleum sources, the biodegradation is much lower compared to the craft lignin substituted foam. So then degradation rate actually improves. So how do we measure the degradation rate? It is basically the we take the weight, the mass of the foam that was initially there, and with time there is a change in mass, so that is what the degradation rate means. And so if you look at under the ACN, so we also look at how, because it is solid, you cannot measure the other parameters like BOD, COD, and all that. So we have to look at basically under the microscope how the foam has been degraded. So then with 0% craft lignin, that means it is basically phenol formaldehyde resin foam, and then it is pretty solid. It's had very very small amount of degradation, but with craft lignin you can see that it is getting disintegrated. But remember, this is only up to 15 days of data. And then how the compression strength is also important, because when you pierce a flower through this foam, it has to be strong enough. So then 20% craft lignin is also gives a good compression strength. And this is also biodegradation, and the biodegradation is also relatively quite okay, good. So then we looked at the mechanism of biodegradation. So this is basically uh, the biodegradation happens due to this lacus enzyme, which is basically a catalytic oxidation reaction. And so this would be the, if it is lignin polymer, that lacus actually attacks, and then we typically get this type of intermediates. And so we haven't completely done all the GCNS analysis, but some of the compounds can be identified. For instance, catechol, you could see that there was some production of catechol. Then this would be the metabolic. So this is the A is a degradation of craft lignin via lactase oxidation, whereas the B is basically depolymerized lignin molecules. So then we are starting with a smaller fraction because it is depolymerized, and then this is what the degradation pathway. Again, we haven't measured all the intermediates. Some of the intermediates could be measured, and so then finally it should be giving us CO2 and water. Um, so this is again, I think I'll skip this one because there's no point in showing the biodegradation pathway. Okay, so we also use lignosulfonate instead of lignin. Also use lignosulfonate, and then
Excuse me,
again
ma'am.
it goes to the similar type of first resin synthesis, and
Ma'am, you
then
have,
forming
ma'am.
of the resin along with all the curing acid and surfactant and synacetic, and then it is
Sorry to
another
interrupt, ma'am. You have
uh,
2 minutes more only.
instead of lignin, we also use lignosulfate compounds, and then we are just looking into their biodegradation. So our objective is to make these products from waste, which is, one of the aspect of resource recovery.
Can I
And we
interrupt you, ma'am,
have
in between?
agricultural biomass, or this in this case that uh, it's biomass coming from the craft
जा नहीं
people
रही
mill.
आवाज उनके पास.
And here again, doing the biodegradation with LFS and
यहाँ से
depolymerized
एक मिनट.
lignosulfate based
आपके वाला स्क्रीन
foams.
कहाँ है?
So again, that we see
हाँ ये
that
वाला है ना.
there is comparable
नहीं म्यूट तो नहीं है मेरा.
biodegradation with
मैम का करना,
both
मैम का.
lignosulfonate
मैम का
PF
करना.
resin and the
म्यूट करेगा तो आवाज़ सुनाई देगी.
depolymerized
इधर आओ.
lignosulfonate PF resin.
म्यूट
And it
तो
is
कोई भी नहीं
similar
है.
way
ये
of
वाला
being
करना
done
सर.
that
ये वाला
due
ऑन
to
करना.
the weight loss or
नहीं ये नहीं है.
different
ये मैंने
time
बंद ही
and
कर
for
रखा है.
different substitution of this lignocellulose,
मैसेज तो कर देना.
lignosulfate, and then also looking into the ACN pictures. So this is how the ACN pictures would look like, and how there with the increasing lignosulfate that there is a bit more higher
Excuse me, ma'am.
biodegradation. Again, looking into their pathway for degradation. So this work is done in collaboration with microbiological lab at Lakehead University in Ontario. So then we also look into that the seed germination
कर
studies.
दिया है.
So then this is basically that 30% LSPF resin and then commercial PF. This is commercial phenol formaldehyde resin. So after 7 days, they have very similar germination stage. But if you have after day 9, it seems like the commercial PH resin was performing better. It's kind of stagnant here. But yeah, so then it performed well in terms of seed germination. But after that, the plant growth was definitely the commercial PH resin was better. This is where we need to look into the why that the growth has been stunted after some time. But initial germination stage, it was performing as good as with a commercial PF resin. So this is where right now we are looking into what is the reason for it. And then also this particular slide shows we did some dye absorption.
मुझे
So
नहीं
it
लग
is
रहा है कि मैसेज
not for
देख रही है.
only germination or floral alignment type of work. It is also for the uh, industrial effluent treatment, like if we can use the same foam for dye removal and as well as phosphorus removal. So the idea is that if we can remove phosphates by this foam, and then that can be used for germination, because as you know, the recovery of phosphate from different effluent has become a very important aspect of sustainability, because the inorganic phosphate rock is depleting all over the world. There's only, I think, the Morocco has the
नहीं
highest
ये
amount of
नहीं हो
phosphate
रहा है
rock
ये.
from which the phosphoric acid is
ये
produced.
कल भी
As we
हमारा
know
ऑफ ही
that
था वैसे. ऑडियो
no
सेटिंग्स
life
नहीं हो
form
रहा.
is
नहीं
possible
लेकिन अभी जब
without
मैं बोल रहा था तो मैम को सुनाई दे रहा था.
phosphate. So then phosphate
कल भी
recovery
आपने
from
इधर से ही
different
कनेक्ट किया
effluent
था. कल
becomes
भी
a
ऑफ था
very
इधर से.
important aspect. So these foams can be used for phosphate recovery. So with dye absorption, we do see a very good performance of this foam, and it is very highly. So you can see
मैम
that
कॉल नहीं
in
कर सकती
20
व्हाट्सएप
minute
कॉल.
time that
मना कर रही है.
foam
उनकी
can remove
सुपरवाइजर
almost
है ना.
80-90% of the dye. This is methylene blue that we used, and typically capacity would be like several hundred milligrams per gram. So the capacity is also comparable to commercial activated carbon. And so it is, but only problem is that it is highly pH dependent, and the better performance was seen at higher pH, pH 10, but pH 7 is not very bad. It's actually around. Yeah. Hello?
Can you listen me?
Yeah.
When you had only 2 minutes to left finish that.
Okay. Yeah, yeah, sure. the phenol to, formaldehyde to phenol ratio of 1.8 was ideal. Initially, we tried to optimize all the parameters for producing a good resin, and after that, a good foam. And so then for F over C, which is basically formaldehyde to phenol ratio, 1.8 was found to be good with structural integrity, uniform pore distribution, and strong mechanical properties. Then we use craft lignin substituted phenol, craft lignin instead of phenol. So produce foam from there, and it shows very high hydrophilic properties with open cell porosity close to 100% and water absorption capacity of 2100%, and water uptake rate of zero point 0.9 centimeter cube per second. These foams also exhibited biodegradability of approximately 68% within 15 days. Then we also use depolymerized craft lignin, and this also showed very good water absorption. It's higher than craft lignin, is about 2500 percentage, and also low density and near complete open cell content. And biodegradability was lower than the craft lignin. It was only 39% after 15 days. Then we also use lignosulfate based foam, which achieved also very good absorption capacity, rapid. This one had the highest water uptake rate and biodegradability of 65% over 15 days under similar condition that with the craft lignin. And also these foams could remove some of the methylene blue dye and also phosphorus from it needs some sort of surface modification to get phosphorus or rather inorganic phosphate from solution. So with that, I want to acknowledge the funding source from NSERC, which is the Natural Science and Engineering Research Council of Canada. AP Innovation is basically for different types of forest, forestry related research, and my tax global for the funding for the students. And then experiments were partially conducted at a different location called IC Park, which is not the same campus as Western. So with that, thank you for listening, and that's all. If you have any questions.
So, thank you, ma'am, for your thoughtful, provoking lectures. Your words will surely inspire us to strive for excellence in the fulfillment of the sustainable goals. So, now the session is open for the questions, and if any one of you having question, you can ask to ma'am.
Hello, thank you for a very interesting talk. I mean, the foam you made from the. Do you hear me or no? I think. Hello?
Hello, I can hear you
There is an echo.
loud.
Okay. So my question is, you made excellent foam with properties similar or better than the commercial petroleum-based phenol formaldehyde. Is there any impact on the cost? How is the cost of your foam compared to the petroleum-based phenol formaldehyde foam?
Is it possible to type it in the chat that I can see? Because I think that
Yeah, just my question
I
is,
cannot hear you properly.
my
Let me
question
see
is
in
in
the
the,
chat,
no,
okay?
there is an echo. My question is in the cost. How is the cost compared to
So
the
how much
petroleum
the
based?
force?
Cost.
Type कर दें.
Are you talking about the force of the foam?
No, no, I'm talking about the cost.
Oh, cost of the foam.
Yes.
Okay, okay. We haven't done any cost analysis, but you have to see that instead of using phenol from, we didn't buy any phenol, it's just craft lignin. We generally coming see from the pulp and paper mills, which is a waste of them. So basically, we use that. So we haven't done. So rest of the steps would be similar to if we had used commercial phenol, the cost would be very similar.
Okay.
That so that the initial feedstock is kind of it's coming from different
Okay.
waste
Thank you.
products.
Thank you.
So otherwise, the rest of it would be very similar because the phenol formaldehyde resin also goes through the similar foaming procedure and uses the same type of catalyst and surfactant and blowing agent. So I think the cost saving would be only in the feedstock.
Okay, ma'am. Thank you so much for enlightening us and giving the valuable talk and joining this conference. Just a minute, ma'am.
Thank you so much, ma'am, for joining us and sparing your valuable time. Thank you so much.
Thank you. So are you going to go to the uh, now the physical lecture, right?
Yes, ma'am. Yes, ma'am.
Next time
Okay,
we want to see you physically in Sharda University.
that would be nice.
Yeah, thank you so much, ma'am.
Thank you so much, ma'am. Now you
You're
can.
most welcome. Where I cannot see you. Where are you?
Can you turn on the camera?
मैम बात कर रहे हैं
सेशन खत्म कर दें, सेशन एंड कर दें,
एंड कर देते हैं
सेशन एंड कर दें,
हाँ, ये वाला एंड कर दो।
एंड कर दो।
एंड कर दो। ऑनलाइन ऑन नहीं है ना मेरा।
हाँ, इसमें लगानी है ना।
It's okay. There's too much of trouble.
यहाँ वेबकैम में दिख रहा है।
आपके पास साथ चलेगा, वो उसमें बन जाओगे ना।
यहाँ पे यहीं से होगा मैम यहीं से होगा
वहीं से होगा।
अब ऑनलाइन ले लें।
Yeah, okay.
चार्जर
Bye. Bye. Bye.
So, ladies and gentlemen, it is our honor to introduce Professor Venkatesu, whose contribution in the field of thermodynamic and physicochemical property of novel class of ionic liquids and liquid mixtures, protein folding, unfolding in presence of covalent solvent have left a indelible mark on both academia and industry. Professor Venkatesu Professor Venkatesu is Professor of Chemistry, Delhi University. Sir has completed his PhD from Sri Venkateswara University, Department of Chemistry, Tirupati. Sir has done his postdoctoral work from various prestigious institutes uh, uh, like the University of Texas Medical Branch, National Taiwan University of Science and Technology. He has also received various prestigious awards. He has received Dr. Arvind Kumar Memorial Award by Indian Council of Chemists. He received Professor Suresh C. Amita Award by Indian Chemical Society. Also, Sir has received bronze medal from Chemical Research Society of India, Bangalore. Sir, research areas include the thermodynamic and physicochemical properties of novel class of ionic liquids and liquid mixture. He is also working on protein folding, unfolding in presence of covalent solvents, effect of polymer chain in coexisting liquid phases. Sir is also having various funded projects from the DST, CSIR as well as DBT. Sir has more than 260 research articles and he is also editor of various research journals. With this, I welcome Sir to enlighten us for your valuable talks. Please, sir.
Okay. You don't have pointer. Okay. Otherwise, you don't have mic.
Sorry.
No, this is not required because otherwise your hand. Okay. Thank you very much for your nice introduction. First of all, I would like to express my sincere thanks to Professor N.B. Singh and Professor Anupam Agarwal, who are invited me to present recent developments from my research laboratory. Now I'm going to talk about. Now I'm going to talk about sustainable solvents for pharmaceutics, the role of ionic liquids and diuretic solvents in pharmaceutical formulations. मुझे दे दो मुझे साइड पे ओके Okay, so now I'm going to talk about the role of the ionic liquids diuretic solvents in the pharmaceutical formulations. So mainly we are working in the field of protein folding stability in the biomass, protein folding unfolding studies in the ionic liquids diuretic solvents, and protein folding studies in the nanoparticles. The polymer phase transition, mainly we are working on polymer and protein biomarker interactions. And the last one, but not least, bio or nanocomposite formations between polymer and nanoparticles. So now mainly I'm focusing to discuss about protein folding, unfolding studies in the ionic liquids and diuretic solvents. So as we know, everybody is facing different kinds of stresses inside the cell. Mainly we are having the stress, heat effect, pH changes. If you have different kinds of pH, then we have different kinds of stresses. Radiation, cold, concentration effect, and environmental effect. So every organism, including us, we are facing different kinds of stresses. If you have too much stress on us, then what will be happening? The organism is going to denature. So my main concept is how to control these kind of stresses and sustain the molecule. So then you can see here, this is the, for example, you may take protein. The protein is having different kinds of stresses, chemicals, mainly denaturants or any acid, something like that, then pressure and heat. So if you apply these things, what will happen? The organism is going to denature. Now, how to control these denaturant action? So for that, if you add kind of co-solvents, these co-solvent you can see here, this co-solvent is giving protection from chemical changes or pressure or heat and other stresses. Then these co-solvent give protection. Now, we have to find which co-solvent is suitable. Okay, so for example, in chemical point of view, we have mainly organic compounds. So these organic compounds will not help because of these air pollution and ozone depletion and human health related problems. Because of these contributions, these organic compounds are not suitable. Then if you see the ionic salts, for example, you may take sodium chloride or any other ionic salt, the melting points are more than hundreds. For example, you may take sodium chloride crystal, that melting point is 800 degrees Celsius around. So these kind of ionic salts will not help to protect from these kind of stresses. So we can't play with the organic solvents due to their volatile and different drawbacks of these organic solvents as well as inorganic solvents. Then what is the solution? If you see the literature, people has checked too many publications and different research, then finally they got solution the nature as well as the literature has given some kind of solution to prevent these kind of stresses. So we have the source to control this kind of denaturants, mainly using biomass, solar energy, ionic liquids, nanoscience, waste utilization. So mainly the ionic liquids are helping to control these kind of stresses. Let us see how these ionic liquids are controlling. So mainly I'm focusing on these ionic liquids, including dipeptidic solvents also, how they're giving protection against these kind of stresses. So these kind of solvents people recognize as a greenery solvents. So mainly I am focusing on these ionic liquids because they are very stable, and also dipeptic solvents, they are non-volatile and also very stable. So let us see what is the ionic liquids. So ionic liquids, they are very thermally and chemically stable, low melting point, high ionic conductivity, and also high polarity. So negligible volatile. So I'm not going detail about these ionic liquids, but if you see the definition, what is ionic liquid? Ionic liquid is a combination of the ions, cation and anion. Then the question arises immediately. What about ionic salts? That ionic salt is also combination of the ions. So if you compare these two, in ionic liquid, most of the ionic liquids are liquids at the room temperature or below 100 degrees Celsius. And also ion-ion pair interactions, very weak interactions are existing between these two ions. Whereas in the ionic salts, the electrostatic interactions are very strong, and most of the ionic salts are solids. Okay, so that is the main difference between this ionic liquid and ionic salts. So the history of these ionic liquids started in 1990s like a small tree. Later on, it is expanded in different fields. Okay, so it is started in small tree. Later on, it is expanded different scientific fields like a very big tree. So the applications are mainly focusing biotechnology, medicinal applications, analytical, thermodynamics, electrochemistry, organic reactions. People are also working nowadays in nanoscience, nanotechnology also. So like this, their applications spreaded throughout the scientific field. So we have also recently reviewed about these applications. Particularly, we focused on the proteins and the stabilization of biomolecules, something like that. Okay. So if you see the protein functions, okay, so the proteins are very specific, selective, and high activity. Okay, so these, because of these functioning, if you see enzymes or any kind of biomolecules, their functions are very active and they're folded. We are very happy. Yeah, so something proteins or enzymes are getting misfolding or unfolding or getting aggregate, then we have different kinds of diseases. So that's why they're specific, selective, high active. Okay, so now we can see what is protein stability. Okay, so the protein stability we can define as the difference in the free energy change between native state and unfolded state. Okay, which you can see here. This is the folded state. At this state, the protein is more stable. Okay, and the free energy changes are also very high. If you apply any kind of these changes, the protein is getting going to be unfolded state. That means denatured state. So here this is folded state, it is more stable, and this is unfolded state, it is unstable. Okay, so if you have the difference of the free energy between this folded state and unfolded state, that will give the protein stability. So if you have folded state and unfolded state, there should be equilibrium between these two states. So like this, we can define the protein stability. You can see here, when protein is in more active state, that means in native state, in folded state, the chemical bonds, disulfide bonds, and non-covalent interactions are very active, where if you apply heat or pH or pressure, these bonds, non-covalent interactions and non-covalent bonds and disulfide bonds will get broken. Then we are getting protein denatured state. So you can see when a protein is in folded state, then all the things everything is getting okay, and we are also very happy. When the protein is getting aggregation or misfolding or getting many stresses, the protein is getting, then we are very protein is getting unfolded state, and we are not that much active. So everything is depending in our human body on the proteins and enzymes, their function, their functional activity. Okay, so if you see the protein stability, mainly we have two types of interactions. The first one is hard interaction. In this we have steric repulsions, and the second one is soft interactions. In this we have electrostatic, hydrophilic, and van der Waals interactions. So mainly these two types are involving in protein folding or unfolding or misfolding or aggregation states or anything. So these are the main interactions are involving. If you see the classification of protein stability, mainly we have three types. The first one is thermal stability. The thermal stability is mainly depending on the thermodynamic profile, that is transition temperature, enthalpy change, free energy change, and etc. And the chemical stability. The chemical stability is mainly depending on the solvent concentrations, and the kinetic stability. Just now I showed you, when you have two states, folded and unfolded state, there should be equilibrium. So using that equilibrium conditions, we can predict the kinetic stability. You can see here, this is the protein folded state, complete native state. When you increase the temperature or increase the denaturant concentration, it may go transition state from folded state to unfolded state. So here we can see the transition temperature. So at this point, this transition temperature, the protein is going to start denature. So these we will call intermediate structures. So at intermediate structures, we have 50% folded structure and 50% unfolded structures. So using this transition temperature, one can say the protein is in folded state or in unfolded state. So mainly we can use this transition temperature as well as also the free energy changes. You can see when the protein is in folded state, the free energy changes are increasing with increasing the solvent concentration. Whereas protein is in unfolded state, the free energy changes are decreasing with increasing the denaturant concentrations. So using these two transition temperature and the free energy changes, one can predict whether protein is in folded state or unfolded state. So fine. So we are working different fields using these ionic liquids and diuretic solvents. So we have reviewed different applications in different journals. So mainly in our laboratory we are using commercially, because since we are physical chemists, so we are using commercially available proteins and biomolecules. So mainly we are working in these biomolecules in our laboratory. So first what we did, we have taken simple glycine, diglycine, triglycine, tetraglycine. Then we have seen the free energy change. Okay, as you can see here, if you increase the concentration of the ionic liquid, the free energy changes are increasing with increasing the concentration. We observed same thing in all four glycines. Okay, later we have taken cyclic dipeptides. So here also we have used different kinds of the ionic liquids. Here also we observed the free energy changes are increasing with increasing the concentration of the ionic liquid. So later we have taken globular protein. This is alpha chymotrypsin, which is folded with two domains and it compressed with 245 amino acid residues. Okay, so this alpha chymotrypsin is having a lot of medicinal applications. Okay, then what we did, we have measured the transition temperature. As you can see here, without any ionic liquid, pure buffer, in the presence of buffer, the transition temperature is 42 degrees Celsius. Whereas if you add the ionic liquids, the transition temperature rapidly increased. You can see here in the presence of triethyl ammonium acetate, the transition temperature is 65 degrees Celsius. That indicates the protein is stabilized. The protein is in folded state up to 65 degrees Celsius. The other ionic liquids are also following same trend. So here we have used different concentration of the ionic liquids. In all these conditions also, this is the pure protein without any ionic liquid. If you add the ionic liquid, the transition temperatures are also rapidly increasing with increasing the concentration of ionic liquid. So this is the free energy changes of the protein in the presence of ionic liquid. This is the without protein, we have free energy change, this one. When we add the ionic liquid, the free energy changes is rapidly increasing. Okay. Then here we have studied the fluorescence spectroscopy with other protein using different concentration of the ionic liquid. You can see here in the low concentration, there is no change in the tryptophan residues. Okay. When we increase the concentration, slightly we observed here red shift, whereas at high concentration, we have seen complete red shift. So that means at low concentration protein is stabilized, whereas at high concentration, protein is getting unfolded. Okay? So that means this protein stability, we can say concentration dependent of the ionic liquids. Later we have seen the bromelain. This is extracted from pineapple. So here also we observe same conclusion. All transition temperatures are increasing with increasing the concentration of the ionic liquid. So this is also, we have performed differential scanning calorimeter, this transition temperature. Here also we observed same conclusion for beta lactoglobulin. Okay. Then this is a very interesting work we have done recently. See, this is the IgG immunoglobulin. Mainly it is presented an antibody in our human body. When corona came, that time mainly the virus attacked this immunoglobulin only. Okay. So here we have studied CD spectroscopy and also secondary percentage of secondary structure. In all cases, if you use the choline based ionic liquids, the stability of IgG is rapidly increasing with increasing this ionic liquid concentration. You can also see here the transition temperatures are increasing with increasing the concentration of these choline based ionic liquid. Okay. Then here we have calculated heat capacity changes also. So these also supporting with this transition temperature conclusions. Then hydrodynamic diameter also we have measured using dynamic light scattering. So here you can see the size of this protein. This is 12.9 something, 13 point something, 13.48 nanometer, the pure IgG size. When we add the ionic liquid, you can see here the size is not increasing. So that means the size is maintaining the structure. So that means we are not getting any aggregated structure. So if you have aggregated structure, then it will be a problem. Everything will block in our human body. But our ionic liquids are not enhancing the aggregation size. They are maintaining under the native structures only. Only here at high concentration, they are getting little bit higher. That is also not much variation. Okay. So these all are almost experimental error only. Okay. So that's why these ionic liquids are not enhancing the aggregation size. Then we are also working dipeptidic solvents. So this dipeptidic solvents means you can see here. So this is a hydrogen bond acceptor. This is hydrogen bond donor. So when you mix these two, the temperature is getting very eutectic point. So these point we are calling dipeptidic solvents. So these dipeptidic solvents are also very biocompatible for proteins. So here also we observed, we can see here, same alpha chymotrypsin we have taken. The transition temperatures are increasing with increasing the concentration of dipeptidic solvents. This is FTIR spectroscopy. You can see here there is no any shift. There is no any vibration, sketching vibrations, mainly amide 1 and amide 2 when in the presence of this ionic liquid. If you have shift, any red shift or blue shift, then we can say the amide bonds are disturbing. That means protein is getting unfolded state. But here we didn't observe any shift. We are maintaining the structure is amides are maintaining in properly. And this is also Raman spectra. Then we have calculated this transition temperature, other thermodynamic profile using this dipeptidic solvents of this IgG. So here also you can see all the transition temperatures are very high when you compare to the buffer point. So then we have studied the HPLC and percentage of the size. So here you can see the size is also not much varying. This is the red color is 1 day, and this is 20 days. You can see this is 20 days. The size is little bit higher, but in the presence of ionic liquid, the size is maintaining. As a function of time also, the particle size is not increasing, it is maintaining native structure. This is the conclusion from the diptychic solvents. They are very good stabilizers. And coming to, so far we have seen ionic liquids, diptychic solvents, they're stabilizing the protein structure. Now we have to think about what is chemistry behind this stabilization. If you see, this is the protein. When we add the aqueous ionic liquids or diptychic solvents, first the hydration layer is forming on the surface of the protein. So this is the hydration layer on the protein surface. When we add the ionic liquids, these ionic liquids are trying to interfering this functional groups of the proteins. But due to steric repulsion, these 2 minutes. Okay, so only 50% done. Okay, okay. So you can see here, this is the steric repulsion. Because of this steric repulsion, these are not interfering into the functional group. So this is the main mechanism. Now this is destabilization. I'm not going for detail. The main thing you can see here, this is the contracting effect. What is contracting effect means? The denaturant is destabilizing and osmo ionic liquids are stabilizing. So if you combine both things, this ionic liquid is controlling this action and keeping it to the folding form. You can see here, this is the denaturant and this is the ionic liquid. If you combine both, this ionic liquid is controlling this action and keeping it to the folding form. So we have also studied refolding. Refolding means you can see here, in the presence of ionic liquid, this is the native state and this is the refolding state. Both aplicities are matching. Okay, so in this way, these ionic liquids are behaving as a refolding actives. You can see here in this result. So this is the buffer point, and this is the urea completely denatured the NMR peaks. If you combine these two things, this ionic liquid is controlling this urea, and again it is renaturing. So this is refolding. Some of the results are highlighted in organic biomarker chemistry. So this also refolding studies. And cold, at low temperature, you can see here, at low temperature also, these ionic liquids are giving protection. Then this is also very good results. We have got very good activity in the presence of these ionic liquids. Oh, this is very much interesting results. At low pH, you can see here, at pH 2, the protein is completely denaturing. When we add the ionic liquid, at low pH, you can see it is maintaining the transition temperature is very high. So that means at low pH also, these ionic liquids are stabilizing. So these are very, very good results. Recently we observed, you can see when the proteins, the beta sheets are increasing, then in our brain, the beta sheets are increasing, the fibrils are forming. When fibrils are forming, we got memory loss and Alzheimer's diseases. Okay, you can see this is the beta sheets. So this is the native protein. So if you keep high temperature or low pH, beta sheets are forming. So when we add the ionic liquids, these ionic liquids are controlling these beta sheets. So that means somehow they are helping to Alzheimer's diseases. You can see here very clearly. So this is the native state protein. So this is incubated. The protein is getting aggregated. So aggregated, that means fibrils form. When we add the ionic liquid, you can see whatever you have seen these fibrils are completely controlled. Whatever you have native state, the same native structure we have obtained using TEM images. So this is very beautiful results we got. Later also we have seen AFM measurements. In the AFM measurements also see this is native structure AFM. So this is completely fibrils form, that means Alzheimer's diseases. Then when you add the ionic liquid, so this ionic liquid is controlling, you can see these images and these images are almost matching. So this is also other results. This you can see here we are studying the biomass also. So here we have taken some grass in front of my laboratory. So there we have seen, we extracted salvothermal treatment, some particles. So these particles are also helping to the protein structures, and these results are very good. After preparing juice, we are getting pulp, the waste material. From that waste material, we have did salvothermal treatment. Then we got some kind of material. So that material is also helping to the protein structures. So this is very, very recently we have done. You know the corn. So after corn we are eating, the waste we are throwing. So that waste material we have taken, then we extracted some kind of biomass. So that biomass is also giving support to the protein structures. So that's why we have to use the utilization, waste of the utilization. So that waste material is also helping to the protein structures. This is very recently accepted in ASA Sustainable Chemistry and Engineering journal. And this is also very good results for real application on our human body. So people are suffering diabetics when the insulin structure is getting unfolded or aggregated structure. So that is the main diabetic problem. Insulin is presented in our human body. If the insulin structure is disordered or unfolded, then we have diabetic problem. So what we did, we have taken same insulin, then we added green tea. Okay, so that green tea is stabilizing the insulin structure. So it means if you have diabetic, then if you add the green tea, if you take green tea, that green tea will suppress the aggregation of the insulin and protecting, giving to the folding structure. But people are what they're doing, if they're taking green tea, then they are adding sugar. So if you add the sugar, that sugar will form aggregation, then you will have more diabetic problem. So what we are suggesting in this work, if you take green tea, that green tea is stabilizing the insulin structure, somehow controlling the, somehow, not totally, your diabetic problem. If you add the sugar, then you will get aggregated structure that will cause us too much diabetic problem. So this is also other results we are working with ionic liquid modified gold particles, gold nanoparticles. Then I'm coming to the conclusions. So whatever we have seen, different kind of stresses. So as per this presentation, these ionic liquids, including diuretic solvents, okay, so this all are controlling whatever we have seen, heat effect, pH changes, or radiation, cold, or concentration effect, environmental effect. These all ionic liquids are controlling these different kinds of stresses and keeping into the folding form. So recently, some of my results are highlighted, selected, hot article in PCCP. Then some of the results, very recent results, are highlighted in ASA Sustainable Chemistry and Engineering cover page. So this is mainly interaction about the diuretic solvents and polymer. We are developing the drug. That drug is helping like this. So far, when proteins are presented in our human body, if the proteins are folded, then we are very happy. If the protein is misfolding or getting aggregation, then only we have different kinds of problems, different kinds of diseases. So how to control this? For that, remember to laugh, don't forget to relax and enjoy, and face the challenges carefully, then all proteins will be perfectly working on our human body, then we all are happy. So these are my students, those who contributed this lot of this work. So he's Pankaj Attri, now he's associate professor in Japan, and he's PMS Reddy. He is working in IOCL Panipat as a chemistry quality officer, something like that. This is Avanish Kumar. He is the main author of the chemical review, which is the impact factor is 48, something like that time. Now it is 60 or 70. He is worked in MIT, Massachusetts Institute of Technology, postdoctoral fellow. Now he is in Vibro University of Israel, and these all are working in different colleges. So these recently, not recently, these all are working in abroad only, different countries. At the moment, these are the working in my research laboratory with different research interests. And finally, I want to acknowledge the financial support from Department of Biotechnology, CSIR, SERB, DST, and we have good amount from the University of Delhi, that is Institute of Eminence, and last but not least, the organizing committee of this International Conference of Cutting Edges of Science, Sustainable Development, particularly Professor N.B. Singh and Professor Anupam Agarwal and other team members who has given me opportunity to discuss in front of you this morning. Thank you very much for your kind attention. Okay, so this indicates if people are working in ionic liquids, be positive, there is no negative thought. Okay, thank you very much.
Thank you so much for your valuable talk on ionic liquids and protein aggregations. So now the session is open for question. If any one of you having question, then you can ask.
Yeah, please, sir.
Sir, it was very wonderful talk. I just want to know basically what happens inside our body. Chaperones does all the work, okay, and it assists in protein folding, and also every proteins has half-life. So this ionic liquid, when it is done in vitro, did you check some of the half-life of the protein? Does it change the half-life of the proteins like?
We did these all things are in vitro only.
Okay.
Okay, vivo we didn't try.
Okay.
So this half-life we didn't try.
Okay. Because exactly the ionic liquid will assist the stability.
Yes.
So if we can check the half-life, then we will be able to know how much, because in vitro the proteins are stable when you make lyophilized form.
Yes.
It remains in the lyophilized form.
Also have cases where
Yes. So if the half-life can be checked, then it will be helpful for knowing the proteins, how it works in vitro as well. Thank you so much, sir.
Okay, thank you. Excellent talk. I learned a lot of proteins, and this is definitely not my area, but thank you. This is very enlightening. Just my question: you have shown like different ionic liquid can stabilize protein, etc. Have you gone to any like next step? Did you ever go one of your material to like clinical trial or something like that for
Clinical
certain?
trials.
Yeah, did you try?
clinical trial we are thinking, actually we are physical chemists, we are not gone that much depth. So now we are thinking to make collaboration some biological
Collaboration, yes.
people. Then we can see the vivo also.
Sure.
Yes,
Okay.
sir.
Okay. Thank you. Thank you.
I have just one query, not a question.
Sir.
You have focused on inorganic materials like ionic liquids or deep eutectic mixtures. There are a lot of organic eutectic mixtures whose melting temperatures are below 50 degrees centigrade.
Yes.
Variety of organic
Yes, sir.
eutectics.
There
Can they not be used?
we can, sir. I didn't gone that much detail in diabetic solvents. There are a lot of diabetic solvents, organic related things that we can use, sir. Yes.
Thank you so much, sir. This was really a wonderful talk, and we were just looking on the screen like what you are now revealing. Yeah. So one question, as I also reviewed this ionic liquids for polymeric reactions. So my question is, did you synthesize any of the organic liquid, ionic liquid in your lab, or
yes, we
so which
synthesize
can
many
you?
ionic liquids we synthesized.
Okay.
Many ionic liquids we purchased also.
So mainly on what type of ionic liquids you are
See,
working?
in our laboratory we synthesized ammonium-based
Ammonium-based.
ionic liquids
Okay.
and polonium-based ionic liquids.
Okay.
This imidazolium and phosphonium-based ionic liquids we purchased.
Okay, so how do you ensure about their purity? Because when I was reading the literature, then purity is the major concern of ionic liquid.
Titration, I forgot which titration that is. Water purity we can determine that using that titration.
So request you to share one or
Definitely,
two
definitely.
publications where you have
Definitely,
synthesized the
definitely.
ionic
We have a
liquid.
lot of work we did in this field.
So,
we have
yeah.
different field, thermodynamic field, protein field, polymers also we have worked with this ionic liquids. I will share.
So I'm more interested in synthesis of ionic liquids.
Yeah, we have. I think one girl is synthesizing in my lab, Pooja. Not Pooja, Bindu. Recently, we have synthesized polonium acetate ionic liquid in our laboratory. So,
So I'll surely be following your article if it is published.
Sure.
Thank you so much, sir.
Thank you.
Yeah.
Sir, I also one question.
Please, please.
So, actually,
He is biochemist, so that's why.
so sir, I'm a biochemist. So, when I was doing my postdoctoral study, I was working on protein telomerase, which is a ribonucleoprotein. So, I was trying to purify that protein from bacteria, but it was not.
We are not doing. Don't ask that.
Let me ask the question, sir. So, but when I then I found the I was doing troubleshooting it. Why it is not? I am not able to purify that protein from bacteria, but in mammalian cell it was easily purified. So I found that there is some folding issue in bacteria happen. So, did you have some have done any work on the protein which has very high molecular weights? For example,
These all are alpha chymotrypsin, IgG. These all are high molecular weight.
protein which have above 100 kilodalton
Yes,
and
this
150.
145 amino acid. This is, I think, 24 or I don't remember exactly.
Okay.
This all are. This IgG is also approximately 100 kilodalton.
Okay, okay, okay. Okay, sir. Thank you. Thank you so much, sir. So, now I request to Professor N.B. Singh, sir, to felicitate Professor Venkatesh by presenting a memento. Thank you, sir. Thank you so much. So now it's our honor to introduce Dr. Vipul Sarkar. Dr. Vipul Sarkar holds a PhD in heterogeneous catalysts from Academy of Scientific and Innovative Research. Presently, he is a senior scientist at CSIR, Indian Institute of Petroleum, Dehradun, where he and his work group is working on a new routes of petrochemicals in association with the private sector R&D, oil PSUs, IITs and central universities. He has published several patents, papers, peer-reviewed international journals. Sir has also received various type of awards, and sir has also supervised PhD scholars. He has under his supervision 4 PhDs are awarded, and currently also 4 PhDs also ongoing. Sir has also supervised 13 PG projects and 1 PhD student as a co-supervision under his supervision. With this, I welcome Sarkar sir to give a talk.
just try to finish within the time barrier. हाँ ये फ्रंट वाला लाइट अगर ऑफ कर देंगे तो बेटर है. So very good morning. So my name is Dr. Bipul Sarkar. So I am from CSIR Indian Institute of Petroleum. So today I am going to touch upon the sustainable aromatics, our path to net zero. So what is net zero? Obviously everybody is looking for net zero, and India has announced the total country's economic sector will be net zero by 2070. So before going to the presentation, I would like to share some glimpse of my institute. So as you know, I am from CSIR Indian Institute of Petroleum. So the institute established in 1960 to provide S&T support to the hydrocarbon industry. So initially it is been under collaboration with IFP France. It is the major stakeholder of Annex right now. And we are one of the 37 national laboratory under the umbrella of CSIR. So that is whole about CSIR. And the vision of our is we provide technical support, technical service, and technical solution to the hydrocarbon and energy sector. So by meaning the technical solutions, we provide training to the all government PSU ranging IOC, BPC, ONGC, and else. Now, coming to the topic, why renewable aromatics is so important nowadays? Obviously, the first thing is renewable aromatics important because they can help the chemical industry to reduce dependency on crude oil and make the environment friendly. If you consider the crude oil, so we observe that the very high volatility in crude oil price. So when in 2009 the per barrel cost goes up to $100 per barrel, when during the COVID it slumps back to 40. So that particular volatility having a very good market pressure, which forced that bio-based feedstock come into the market. So what bio-based feedstock will offer? Obviously, they offer sustainability, reliability, low cost, and it is abundantly available. So if you talk about is our country is capable to transit, obviously we can be capable. It is we have 230 million tons of biomass potential of India, and that total biomass is enough to support Indian growing market of bio-based chemicals, which is currently 1.5 billion, and it is trajectory is 4.5 billion in 2028. Now again coming to the point, so what about aromatics? So if you consider the aromatic market, it is currently incremental growth is 954 $1 million, and it is growing at a rate of 3%. See, for ourselves 3% is a very nominal value, but for a market, for a economy, 3% makes a huge value. So obviously the disadvantage of the fossil resource, obviously the volatility crude is the point, and again that emission of greenhouse gases will affect the UN SDG, that is Sustainable Development Goal. So I am not going into the climate changes as because I know already you know it better. But again, if you consider the volatility of the market, so the whole that represent the crude oil demand, and into that particular crude oil demand, the chemical feedstock industry is consuming 12% in 2017. 2030 it is projected to be 14%, and 2050 it is projected to 16%. And why, from where that trajectory is coming? Because of the shift. We are moving to EV nowadays. So if EV will be running in our road, obviously we need less oil. When the industry have less oil, they need profit. Industries always need profit. So they're gonna shift themselves to petrochemicals. So if you, and the net zero push is doubling India's biomass aromatic market, and which is surpass 6.1 billion by 2034. Now, obviously, so those are the projections, but does industry have any technology which can support those projections? Obviously, industry have some. So if you consider aeroforming, that is IFP's process, it consider naphtha and LPG as a feed and converting that C6 to CX aromatic 60%. Then that is Z forming, it is Mitsubishi's technology, M forming, mobile oil technology, and cycler process. But the one thing to note, the all feed is from crude oil. So there is no such technology exist where that renewable come into the picture. Obviously, research are trying, but those are in field stage. So you have enough market potential as well as you have scope for innovation. Now, coming to the point, how does biomass fit into that particular picture? Obviously, biomass can fit, but nowadays what is going on is biomass majorly being depolymerized to either alcohol or neither phenolic based product. Now, phenolic based product is very hard to extract, and the extraction cost on the separation cost is so huge that those process doesn't make any sense in when the economics comes in. So what next? So we have identified some gap. If you consider the non-edible seed oil and the waste cooking oil, India have both have high potential in India. So that to aromatics hydrocarbon is rarely reported. It is never been reported. And aromatic have been considered the byproduct of those bioprocesses where the aromatics is mainly oxygenated aromatics. It's phenolic aromatics. Emerging Indian demand is have a scope of alternating aromatics, and particularly BTX have a very high market value. Now, my lab is focusing on those sustainable development goals: 9, the industry innovation and infrastructure; 11, sustainable cities and commodities; 12, resource consumption and production; and 13, obviously, the climate change. So to cope on those goals, we are concentrating on those kind of feedstock. So those are the renewable carbonaceous feedstock that we gonna use for our process. One is microbial oil, second is tree borne oil, third is waste cooking oil, and fourth, most obvious, the waste plastic. But I am not touch upon the waste plastic part today. And the product we are targeting is aromatic rich fraction, which is benzene, xylenes, LPG olefins, naphthalene, paraffin, alpha olefins. Those are the primary molecule for today's life. Every product you are using must contain those parts. Now, coming to the first part of my presentation, so the production of aromatic hydrocarbon from catalytic upgradation of single cell oil. So I am very happy to say our CSR IIP have a very huge group of biotechnologists, and we have fermented 500 liter, 50 liter, and 5 liter capacity in fully SCADA controlled. So those biotechnologists of our, those guys have given us a scope. Okay, we are producing single cell oil. Can you do something on from it? So obviously we synthesize some catalyst. It is gallium alumina based catalyst. It is very commercial catalyst and very easy to synthesize. And we upgraded that single cell oil to benzene at 450 degrees centigrade. And what we got, it is 84% conversion, 90% liquid is there, 70% aromatic is there, and it is at 400 to 450 degrees centigrade under atmosphere pressure. Now, what does single cell oil contain? Obviously, we do the FM analysis, and it shows that it is methyl linoate, palmitate, and oleate. The major portion is from those fatty acids, and CHNN analysis shows it have nitrogen and sulfur, and it has certain percentage of oxygen, which is ranging 7 to 10. And those are our reactor, typical reactor on which we are working. We have couple of them. So that reactor have a capacity of 2 to 5 gram of catalyst, and we have various type of reactor ranging from 1 gram to 200 grams. And what we got on a gallium alumina catalyst, we got 89% conversion. The aromatic is 77%, in which 66% of that particular one is the light aromatics. Now, one thing to consider, if you talk about aromatics, you have a full range of aromatics, right? But where the value is C6 to 68, C8. So there is the value. Now, that benzene content of it is 4%, toluene is 62%, and those xylenes is something near about 8%. And in xylene, especially the paraxylene makes very good profit. So if you consider to any refinery make profit by not selling petrol, diesel to you. Refinery make profit from two products. If it having a paraxylene complex, obviously it makes profit from paraxylene. And if it have a cracker, then it is propylene. So the refinery makes profit from two products. One is paraxylene and next one is propylene. So our target is we can produce paraxylene more, then it will be very beneficial for the industry. And that particular work is published in ACA Sustainable Chemistry 2009. Now coming to the next topic, now those tree borne oils as an alternative source of carbon. Now those TBO is promising for biofuel production. Till now it is been considered for biofuel production. And India and 12th year plan launches a mission 3 for oil seed and oil palm for biodiesel mission. Now what is the problem with biodiesel? Because India is looking for biodiesel for so long, but till now no commercial exploitation been happened, because biofuel causing blocking of engine. The most eminent problem of it is choking the filters and atomizer of the engine, and no engine manufacturer is allowing you to use biofuel on their engines. And the high viscosity and phase separation, if you if you just store a biofuel on your desk and few days after, you can see it is settling down. The settling obviously have a engine performance drawback, and obviously the NOx and SOx is another emission which need to be considered. So our idea is, how can that renewable non-edible oil could be a promising option then for the renewable aromatics, the petrochemical basically. Now continually we have UCO. Now India have a very vast importer of the edible oils, and that edible oil after 1 or 2 use having a total polar compound of 25%. Now Food Safety Authority of India has declared that any oil, any used oil have EPC beyond 25% is unhealthy for your health and should be discarded. But India have 3 million tons per year of UCO. It is either discarded or rerouted for secondary use. वो जो street का vendor है वो लोग use करता है यही oil लेके. So why cannot we use that particular available feedstock for our petrochemical business? Obviously, I am very honored to inform you that IIP have a prior technology to use that UCO to aviation fuel. And with the IIP's technology, Indian Air Force have flown several planes, including the AN-232 in the Ladakh region also. So now, coming to the point again, we use zeolite to upgrade the UCO to aromatics. The zeolite is basically ZSM5. I'll talk to you later. And the conversion that we got is 92%, and the 65% is the C6 to C6 aromatics. 12% is the benzene, where the xylene content is almost 20%. Now, we consider that particular result is a very good, as because we have been approached by Hindustan Unilever. So if you don't know about Hindustan Unilever is the market leader of those cosmetics and your detergent industry. Every detergent you use is mostly from Hindustan Unilever. So Hindustan Unilever also have a net zero initiative. They want to become net zero by 2050. And that's why they are looking for benzene. They need renewable benzene for some sources, and from that they will make linear alkyl benzene, which is the surfactant for your surf and detergent industry. So we are now holding talk with Hindustan Unilever, and we are very hopeful that we make a good project from them with them. The next one is that TBO. Now, now as I told you, India have a very vast potential, 0.1 to 20 million tons, out of which 20 to 25% have only utilized in here, and it have a oxygen content of 10%. On that TBO, we took two oils. One is neem oil, those two oils, and another one is jatropha oils. Both are vastly available in India, but on a segregation basis. On that neem oil, we developed a zinc Y-zeolite catalyst, which is giving me 70% C6 to C8 aromatics, 3.2% benzene, and mostly meta and paraxylene. If we use Zetropa oils, we use a multifunctional zinc cobalt zeolite catalyst. It is giving me 71% C6C8 aromatics, 30% toluene, 6% benzene, and metaxylene is 16%, 9.5% is paraxylene. All those work have been published in ACS Applied Material Interface and Renewable Energy. Now, those are the work that we are doing, but what about the reaction network? So why do I call it reaction network rather than reaction mechanism? As most of the Indian researchers, we are taking a model feed, but we never do study those model feed. Rather, we always go for the real time feed. So if you consider real time feed, it is a mixture of 1,000 compounds. So 1,000 compounds breaking into another 1,000 compounds, it makes it very complex to precise mechanism, for a precise mechanism. That's why we call it reaction network. It's a network. It is not a mechanism for us. So that is a reaction mechanism that we will be discussing now. But before, I want to introduce you with the zeolites. What is a zeolite is? Zeolite is a framework structure. Those structure is 3D framework structure. It is normally silica aluminates, and it's. I hope you guys know those zeolites is the backbone of catalytic conversions in industry. Every industry you go, they must have used zeolites on their processes. So see, if you see that particular zeolite, it having a 4-ring. It is zeolite sodalite. It having a pore size of 2.3 Armstrong. That 8-ring zeolite, it is zeolite A, and the king of that particular zeolite industry, ZSM5, also falling on that particular zeolite, 8-ring zeolite, it having a pore size of 4.2 to 5.4. For ZSM5, it is 5.4. And then come a bit bigger zeolite, it is 12-ring zeolite, it is zeolite Y, it is 7.5 Armstrong. Now those zeolite we use for as a support for our reactions. Obviously, it is a support as well as the catalyst also. Now coming to the reaction network, we considered that particular fatty acid molecule as trimethyl octadecanoate, and in the first stage of the reaction, it will be protolytically cracked on the Bronsted acid site. Now where does the Bronsted acid site comes from? That zeolite have provided you a Bronsted acid because of the charge imbalance in the alumina framework. It is that silica alumina framework that I am talking about. So it is primarily cracked to methyl linoate type of substrate, and then further it will be cracked on Bronsted acid side, forming those olefins. Those olefins, either it can be a terminal olefin or a normal olefin, and that is further cracked on a Bronsted acid side to short olefins, short alkanes, and hydrogen. Those short alkanes and olefins will be cyclized on the Bronsted and Lewis acid side to form cycloalkanes. Those cycloalkanes then dehydrogenate, and that dehydrogenation will essentially require Lewis acid site. Now, where the Lewis acid site is coming from? So the transition metals that you are doping in that particular framework, it is the source of those Lewis acids. So those precise control of those transition metal will help you to optimize those aromatics. Now you are up to that particular mark. Now what if you choose a catalyst which have high Bronsted and Lewis acid? What will happen? Those aromatic will form polyaromatic compound which is neither it is a form of char only. So you will end up with a deactivated catalyst. Now you have to, that is a new reaction network that we are proposing, but we have to prove it. Somehow we have to show, okay, those are the steps it is involving. So what we have done, the product pattern is confirmed by pyroprobe GCMS. So we have a pyroprobe GCMS, and we conducted some model fatty acids for the study. Now the feed we have taken the reference of a feed which mainly contain methyl palmitate, methyl oleate, and methyl linolate. So those are the three compounds, and those are the pyroprobe spectra. If you consider the spectra, you can see those kind of olefins are there. So that proves that this is cracking on the protolytic cracking and forming those. Then you see those cycloalkanes. Now, then you please consider those small alkanes. So small alkane, obviously it will be not in the liquid form, it will be in the gas form. So we have taken the gas from our reactor and we did a thorough analysis by a GC method called GCRGA. It's a refinery gas analyzer, and we have confirmed it contains hydrogen, olefin, and paraffin. Then coming to the part again, then those cycloalkanes is confirming those cycloalkane is appearing because of the cyclization, and further those aromatics is the final product that we are obtaining. And overall, the aromatic yield from TBO is varies between 50 to 60%. It is a weight percent basis, and on which 90 to 15% are benzene and 16 to 25% is xylene. Now those xylenes, Reliance have a big market player for the xylenes, and they will be very happy if we can increase those xylene content, especially paraxylene, up to 10%. Now, what we are doing, so we are finding a new route to aromatics. We took feedstock like TBO, mixed biomass, sugars, waste plastic. So waste plastic I don't discuss today. The process is catalytic fermentation or pyrolysis. We are making benzene, toluene, unique aromatics, and xylene. Unique aromatics contain styrene. Styrene is a very costly aromatics. We also targeting the styrene to be formed, and the end up product is additive coating and plastics. Obviously, if you can integrate those process, you can step forward to the net zero, as because those product will be carbon positive to the current industrial product. Now, the key conclusion is tailoring activity and uniform pore network of the supported catalyst is very effective to convert non-edible seed oil to aromatics. Particularly, C17 to C19 fatty acids can be effectively converted to C6 to C8 aromatics over those modified zeolite catalysts, and promoters somewhat enhance the activity of those aromatic hydrocarbon, but obviously it is the case-to-case basis. Now, that is my whole team. So we have a very good team. So ranging from technical assistant, postdocs, those are my PhD students. Two of them is sitting there only, project associate and technical staff. I am always very happy to my past members of my lab. Dr. Ankit is currently senior scientist at Reliance Industry. Ombir is assistant professor in Rajiv Gandhi Institute of Petroleum. Vivek is assistant professor in Thapar. Minu is currently final year PhD at IITE at Vizag. Mandeep is currently ATGA Laboratory, Canada. Shubham is teaching somewhere in Pauri, Garhwal, I guess. Neha just finished her PhD. Himanshu joined IIT Roper as a postdoc fellow. Ajar found another lab to look in. Sumit just started his PhD. So if you want to know about us more, obviously that is my lab website address, saskiyalab.com, and obviously I welcome you to Catalytic Depollution Area, Indian Institute of Petroleum, Dehradun. You can mail to me or contact me. So we are very open-heartedly welcome you for the collaboration, and I especially want to thank Anupama ma'am for his invitation. And finally, that is our IIP looks like. That is IIP, we call it Eco Campus. The campus is totally plastic free, and those birds are not from the YouTube or Google. Those are the actual pictures. We located in the part of our Rajaji National Park, so we have full biodiversity in our campus, and we welcome you to our campus. Thank you, thank you.
Thank you, sir, for this wonderful lecture. So now the session is open for the questions, and if anyone to ask any question, please.
I'm in time.
Yes, sir.
Yes, sir.
Okay, so have you looked at other type of catalysts? Because zeolite, I think you reach limit on paraxylene, and that's actually, you need to reduce the cost of separation by going to higher concentration of paraxylene, and also the value of your product. So have you looked at other type of catalysts, like 2D material-based catalysts, like graphene, MOF, or
Yeah.
other than zeolite?
So there is two things that playing to for that choice of catalyst. First thing is, if you rely to work with industry, industry is always looking for a established catalyst, established method. So for that, we have somewhat forced to work on that particular domain. But contrary, if you want to explore something new, obviously we have scope and we are developing it. I haven't shown it here. So we are working on zeolitic imidazole frameworks. So those are something new material, but obviously industry is not liking to accept it. So if you consider industry for your partner to go ahead, you are forced to work on those particular domain for which industry feels happy. But obviously for your research purpose, the entire floor is yours. You can make any catalyst, we are working on it.
Yeah, it's also depend. Do you want to go to the industry now or after 10 years, 5 years?
Yeah.
So if you want to also keep the links with industry after 5, 10 years, you need to have new
Yes.
catalysts, etc. I think. Thank you. Thank you.
So a very interesting talk. However, not related to the field which I work upon. But the thing is, it's an inquisitive question. By 2070, we need net zero. That's a target. So the thing you are showing here from aromatics to fuel generation, it looks like very challenging, right? I mean, is there any set example that it's promising to work upon it and we can get results quickly?
See what people is doing. Now government have initiated the blending of ethanol. So that is the one set example which is ruling out now. If you go to any petrol pump, you can see E10, E20. Go to buy a bike, you can have a choice. Either you go for E20, it will be written like E20. So it is ethanol blend. So that is the only initiative which has been rolled out to date.
Okay.
This is because we have established technology, fermentation based sugar bagasse fermentation to alcohol. That is because of that. But to ask you, to reply you better, if you take the case of Unilever. So Unilever, as because Unilever is from Netherlands, so their set target is based on European Union set target,
Yeah.
and their set target is 2050.
Yes.
And they are hunting us. Please give us some technology where can I replace 5% of my benzene to renewable benzene.
Okay, so it is like to have something
Yeah,
in the
to
case
have
when we don't have anything.
Yeah, there is
okay.
another thing to add on. You can see there is some company at UK's largest refinery complex. They come to us. They are telling us, can you give us pyrolysis oil?
Okay.
That pyrolysis oil for plastic. I haven't included that particular part here. That pyrolysis oil, we just ask them why. They are telling us, if we can take pyrolysis oil from Indian origin on that South Asian market, we gonna transport to UK. We gonna process along with the hydrotreater they have, along with the diesel oil, and they will claim carbon credit from the UK government.
Got it.
So
You clarified.
they are taking the help of
Okay.
other country
Yeah.
to show that we are on the way to net zero.
Okay. So it's like
So it's a
something
very
you do,
complex
something I
scenario
do,
right
and
now.
then we move ahead.
It's a
Yeah,
very
okay.
complex scenario,
Yeah, yeah.
and government agency only know where to push, where to not.
Okay. Thanks a lot. Thank you.
Hello.
Yeah.
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 It's a very interesting talk, sir. I just want to know something that UN's most challenging in this area is that the product should not affect health and it should not affect environment. This is the most challenging
Yes.
goal for the sustainable. So your product, as far as I see, it's aromatic renewable. So how much is it going to affect the environment and health in this aspect? This is my first. And the second one is you are extracting it from the oils, these compounds, or you are synthesizing?
Now, we are converting it.
You are
So if you take a fatty acids,
Yeah.
I'm converting it to aromatics.
aromatic, you are converting from the tree
Fatty.
oil.
Now you have a aromatics blend. There is a separate group of ours who gonna deal that particular aromatics to separate out. The separation division, we have a very good separation division.
Okay, okay.
So they gonna take forward that particular part.
Acha.
So one thing to add on, so the if you know Reliance Industry, those guys are so good at picking technology. They never picked a technology from India origin. Never. They are an Indian company, but they never use a technology from India. They always go for outside vendors like UOP, Honeywell, Accents, so on. They never take a technology. They took first technology from IIP for benzene extraction. IIP gave the single standalone technology to Reliance Industry for benzene extraction. So it says that our extraction team is very capable enough to extract all the stream that we have. And for the environmental point of view, every project that we do, before it implementation, it is go for HAZOP study.
Okay.
So in the HAZOP, we can say okay, what is the environmental implication that we can go for, and what is the recycle loop activity.
Yes, because if it can be checked by substituting the renewable benzene, if it's some groups may be substituted and it can have some effect on health,
Yes.
then it would be much better in terms of.
So actually we worked in a team. So my part is this. Those guys will take from there. They will extract the total portion and they will analyze the leftover. Okay, what is the cause of what is the health effect of that, and how you can dispose it.
Oh, thank you, thank you.
Thank you so much. Thank you. Acha, haan.
I have
Yeah, ma'am.
The first question is, you are extracting, say, benzene from plant source?
See, the plant to seed to oil extraction, that oil we converting it to benzene from catalytic cracking.
Okay. So my question is, like in this, because this is a multi-step process, so what is the actual yield that we get, say, any plant when we are growing, say one plant, right?
Yeah, yeah.
And its biomass, say, is 100 grams. Like, so how much are we getting the amount of benzene at the end from that?
See,
What is
ma'am,
the
that we need to look at, but if you consider that oil, if you take 100 grams of oil, we can end up with 50 gram of PTX.
No, that is fine because because it is important to plant that much plants
yes.
to get that much of the benzene. So then also it should be a sustainable alternative than that of the pet, because when we are talking about benzene's consumption at industrial level, it is huge. So if I have to meet that much, then how much percentage I am getting out of this process?
Ma'am, the thing is, we are not trying to change the dynamics. We want you at least mix 10% from bio source. Rest of yours is there. It is coming from petroleum. You cannot surpass petroleum. Right now you cannot.
Okay, because
So in another containary, I'm giving you a small example. That EV that we are running, you know the total statistics. It's never gonna help you and net zero. If you consider a thermal power plant, the efficiency is 32%, 32 to 35%. Thermal from coal to energy, it is 32%. Now 32% you are putting in the grid, that lines. There incurred a loss of 10%. So it is coming to 22%. If you put a battery, those batteries capacity, the utilization of battery capacity is something near about 60% hardly. So from coal to battery, if you are running your car, it is only 12%. You are dragging the energy from coal only, but how much? It is 12%. In compare, if you use petroleum, its percentage is 30 plus, 46 I guess. So it is very complex to see, but okay, industry is looking for to add some percentage from the bio to show okay, we are bit less carbon positive. We are carbon positive actually.
But I think it was Mr. Gadkari's ambitious mission that he wants to replace ethanol.
Yeah. So that is why India's 2G plan been failed. It is considered as a failure. 2G ethanol. It is still 1G ethanol that is ruling out. It is not 2G ethanol right now.
Okay. And second thing, you were saying like you are going in, you are also working in coatings. So what kind of coatings are being?
No, ma'am. We are not going for coating. So we are primarily focused on benzene. Rest of the part, those industry will take forward. So our part is will produce certain percentage benzene to HUL. Now HUL, what they are doing is HUL is importing their benzene from Reliance. They are coping with Reliance to process it to the final finishing product.
Because I think we are again on one more ambitious national mission, that is semiconductor mission.
Yes.
So there a lot of coatings and all these kinds of. So I was just wondering whether you are working on that kind of purity or not, because when we will be needing these kinds of coatings or the solvents to be utilized in semiconductor industry, then they must be ultra pure.
Now,
so
CSIR have another laboratory which gonna work on that particular aspect.
Okay.
So CSIR series, it is on Karikuri. They gonna work on those solid batteries, semiconductors, all those stuffs.
No, I am to only your part, like where you are talking about solvents.
Yeah.
So I am talking about the purity of that solvent. So is India actually working on any of the area where they are really purifying the solvents to a level that they are being utilized in semiconductor industry?
India are doing it. India have those technology, very well established technology. Every refinery have this technology available. So only thing is you need to cope some bio sourced BTX.
So in your like this subsidiary of CSIR, you are working on mainly bio-related solvents.
We are mainly working on petrochemicals. So we are also working in propylenes.
Okay.
We are also working in waste plastic to fuels.
Okay.
So those sort of.
Thank you so much, sir.
Okay.
Thank you so much, sir. So now I request Professor Abdallah to felicitate Dr. Sarkar. So now there is a tea break, 15 minutes. We have a tea break. So after that, again we will be resume in within 15 minutes. So there will be parallel session will be going on, oral as well as poster sessions. Thank you so much.
They'll be giving the presentation on their whatever research topic they have designated. So we shall be starting without wasting the time because already we are running little behind and we have time crunch. So we will be asking Miss Nidhi Yadav to come on the dais and start her presentation.
Everyone will be given a total of 10 minutes. 8
Yeah.
minutes is for presentation and 2 minutes for Q&A. Okay? So we'll tell you when your time is running out. Please note it at 2 minutes and 1
ठीक है,
minute.
ठीक है.
Okay?
Do we have a timer also? So you will be warned 2 minutes before your time to be over.
Did you attach a pen drive?
Yes. पेन ड्राइव में है मैम, मैंने ड्राइव में सेंड किया था.
Okay. Well, technical bit. Which one is it? It's not reading it. Ma'am, it's not reading up in here, I think. Just a moment.
Drive पे थे ना?
It's on pen drive. It's not reading.
मैं प्लग कराऊँ पेन ड्राइव?
ये रीड नहीं कर रहा है, ये वाली शायद.
ये पेन ड्राइव नहीं है, ये
ये
तो
तो
पॉइंटर
SD
का है.
कार्ड पॉइंटर का है ना, वो अपनी पेन ड्राइव में लगाई हुई है, तो यहाँ कहाँ से दूँगा? You everyone who has their presentations on a pen drive, please give it to me so I can arrange it by sequence.
अब इसको अलग लैपटॉप पे करना, यहाँ मत करना.
Opened? This is yours. This is
We'll manage, don't worry.
no, not this. The G1. It's there. This is yours. This now. Okay. Just wait for a moment. Just go on slideshow. Yeah, done.
Okay, thank you. Good afternoon, respected
Start
sir and
timer.
ma'am. First of all, thank you, Sharda University, to introduce myself. My name is Nidhi Yadav, a research scholar of a Department of Chemistry, Tirthankar Mahavir University, Muradabad. This is content discussed with you. Introductions. 2D halide perovskites attached much attention for the supercapacitor applications for exciting properties such as electronic confinement, structural feasibilities, attractive performance, and stability. The use of a 2D halide perovskite in a supercapacitor is because of their potential high charge storage capacities and layer structure show the increased surface area which contribute to the high capacitance and efficient charge transfer, leading to enhance the power density and energy density, which is make it best performing material for the supercapacitor. Supercapacitor structure and a mechanism. Supercapacitors are an electrochemical capacitor. They have an ability to store a energy, fast charge and a discharge cycles, high power density and a long life. The charge storage capacity depend on the type of electrode materials and electrolytes used in a supercapacitors. Their capacitance range is 100 Farad to the 5000 Farad. 2D halide perovskite. 2D halide perovskite are made of the metal halide BX6 octal layered, where B is the divalent heavy metals and usually metals lead or tin, and or X is halide ion, chloride, bromine, etc. Interfaces by the large organic cation is called a spacer. Their general formula A R Ra n minus 1 m n x 3 n plus 1. R is a organic special cation, A is a monovalent, and M is a metals, tin or lead, or X is a halide. N is a number of layered of perovskites. Synthesis schemes. Synthesis scheme, firstly we make a mixture of a tin chloride, HCl, and a hypophosphorus acid. Heat the solution for 20 to 30 minutes at a 60 degrees Celsius for the clear homogeneous solution. Then add a octadecline amine in a mixture and again heat for the 30 minutes at 80 degrees Celsius, then forming the crystals form. Then the solutions become cool down, they form a crystal structure like this 2D halide perovskites. First of all, figure number 1 is show the characterization of a UV visual spectroscopies. Wavelength is arranged in the 300 to 400. The absorbance on set on 330 nanometer, and band gap calculated of a UV visual spectroscopy. The band gap is the 3.7. Next, figure number 2 is XRD, X-ray diffractions. In these, we can analyze the material of a crystalline or amorphous. The needle life structure is show that this is octadecline amine hexaperovskite is a crystalline in a nature. Next is a FESAM, field emulsions scanning electron microscopic. Why images? This figure is show that the layered structure of octadecline amine tin chlorides. And next is the supercapacitor performance. We can check the supercapacitor performance with a CV, cyclic volumetry. In graph, we can see that the curve is X. The curve show the current and the potentials डिफरेंस बिटवीन दिस एंड चेकिंग जो कर्व ऊपर की साइड जा रही है वो शो कर रही है कि ये रिडक्शंस हो रहा है, और नीचे की साइड जो जा रहा है वो ऑक्सीडेशन शो कर रहा है. इन दोनों में हम स्पेसिफिक कैपेसिटेंस पता करते हैं कि व्हाट विल द कैपेसिटेंस ऑफ स्पेसिफिक कैपेसिटेंस. एंड नेक्स्ट फिगर नंबर 5, the performance of a supercapacitor, we check the GCD, galvanometric charge and discharge. The performance of supercapacitor, the curve is go up direction, is show that the charging and down dischargings. And this relations between specific capacitance and current densities. This is table of CV and GCDs, or voltage पे 10, 20, 15 and 100 voltage areas, and specific capacitance show that the 25 and 19, 12, 0, 09. This is the table of a CV and GCD. Summary overall, FSM image show of the octadecline amine tin chloride show the layered structures. From CV specific capacitance and GCT is specific capacitance and a current density. We have received the energy densities and the power densities of the GCDs and the CVs of supercapacitors. They have the scope in improving the result charging and the compositions of electrode materials along the other parameters, and explore 2D halide perovskite, octadecline amine hexaperovskite as a electrode materials. Thank you to my guide, Dr. Minmoy Kumar Chini, for guidance, and Tirthankar University for the grading doctorate fellowships. Thank you.
Okay, so Nidhi, where did you get the GCD done?
Yes, ma'am.
GCD कहाँ से किया?
मैम GCD अपने लैब से किया है.
Okay, so you have, did you make the this coin cells also, battery also?
Battery.
Okay, how did you make it?
In CV, we have reference counter or working counters, and एक इन तीनों के बीच में अपना chemicals mix करके.
Okay, so I just wanted to know, after I think you ran 1200 cycles. In your graph, I could see it was you checked the charging discharging for 1200 cycles. So I just wanted to know how much the efficiency remained after 1200 cycles, because I couldn't see whether the efficiency was remained as such, or if it reduced, then by how much percentage it reduced the efficiency of cell working.
Exactly, I can't remember that values.
मतलब जैसा कि देखो हर साइकिल के बाद बैटरी के काम करने की कैपेसिटी कम हो जाती है ना, तो मैं ये जानना चाह रही हूँ 1200 साइकिल चलाने के बाद आपके जो ये थी बैटरी की जो एफिशिएंसी थी वो अब कितनी रह गई? वो 100% एफिशिएंसी पे तो काम करेगी नहीं, है ना? कितनी रह गई वो जानना चाह रही। सेल, इट इज़ इम्पॉर्टेंट कि आप कितनी देर सेल चला सकते हैं, है ना? अभी आपने उसको चेक नहीं किया, आप निकाल सकते हैं इसी से, यू कैन डू दैट। ओके फाइन, थैंक यू।
थैंक यू मैम।
नेक्स्ट पार्टिसिपेंट इज Nexumi Musa. Who is here? He is absent. Then Shalja, you may please come. Absent है ना Nexumi? तो फिर आगे चलते हैं, है ना?
Nexumi Musa.
नहीं, शैलजा तो आ गई। Next participant is Ankit. So be ready, huh?
पता नहीं मैम, इसमें कुछ नहीं पता लग रहा इसकी है, ये मुझे नहीं पता, ये मेरी तो आपने नहीं जा रहा।
रिसर्च पेपर डिटेक्ट नहीं हो रहा है इसमें।
सर ऑन है पेन ड्राइव, मैंने मैटर किया है मेरे लैपटॉप में, तो
अब इसमें नहीं हो रहा ना पहले।
तो किसी और पे करा लीजिए। मैंने वो कुमार सर है उनको मेल किया था।
अंकुर के नाम से?
हाँ 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 ये है, हाँ ये शारदा शारदा शारदा, ये ना शारदा। पॉइंटर नहीं है सर, वेयर इज पॉइंटर? Good afternoon, all of you. Myself Shalja Singh for Tinthakkar Bahabir University, Muradabad. I am a PhD research scholar. I am doing my PhD under the supervision of Dr. Namneet Kumar sir. First of all, I would like to thank Sharda University for giving me such type of opportunity that I am presenting my paper utilizing zeolites as adsorbent for pesticide removal for wastewater from wastewater. It is widely acknowledged that the world's food output must rise to meet the demands of its continually expanding population. The intermittent use has been having serious negative effect on the food quality and public health, which has led to an environmental burden and ultimately the emergence of pest resistance. A significant waste is produced by overuse and misuse, which raise costs and has a negative impact on environment and human health by contaminating the soil, air, ground and surface water and getting into the food chain as residue. Improper pesticide use and impact on the entire ecosystem, which is very harmful for the human as well as ecosystem. Various agents that are categorized according to their ability to harm living things are referred by the term pesticide. Pesticide include herbicide, insecticide, fungicide, etc. One of the biggest environmental issues of our time is the removal of pesticides from wastewater. Because water has limited source, or we have no water to drink anymore. Combining different naturally occurring materials and environmentally shaped agriculture ways that do not undergo human health with the environment may be the most beneficial course of action
The amount of pesticide residue found in groundwater supplies has increased dramatically, and it is now a hot topic of discussion. Adsorption is a well-known equilibrium separation technique that works effectively for decontaminating water. It has been discovered that adsorption is better than other methods for reusing water in terms of starting cost, design flexibility and simplicity, ease of use and insensitivity to harmful pollutants. Additionally, adsorption does not produce toxic chemicals. Since a wide range of adsorbent materials linked to various processes are available, there are many opportunities to use carbonaceous material, water and wastewater treatment using the adsorption process zero waste approach. For instance, increase efficiency and recovery, the biosorption process need more research in the areas of modeling, biosolvent regeneration, pesticide recovery and waste material immobilization. Waste might include a lot of highly valuable reusable materials. Adsorption is being investigated further, a primary technique for removing pesticides from wastewater. Adsorption is an effective process in advanced wastewater treatment technique to reduce the effluent risks of high pollution. The most advantageous course of action may involve combining various naturally occurring materials, eco-friendly agricultural waste that pose no risk to human health with environment. Freshwater depletion is the mostly cause a range of contaminants and freshwater users. In recent years, adsorption processes have been effective result on water and wastewater treatment technology in different industries. Pesticide can be removed by low-cost adsorbent as zeolite from wastewater. There are so many adsorbents available: carbonaceous adsorbent, agricultural wastewater adsorbents, polymeric adsorbent, industrial waste adsorbent, bioadsorbent, inorganic adsorbent, methylaceous adsorbent. Carbonaceous adsorbent can be removed pesticides from wastewater. Polymeric adsorbent also remove wastewater pesticides from wastewater. Industrial waste adsorbent like sugarcane, bagasse, like rice husk, maize. Bioadsorbent, the term biosorption refers to a variety of metabolically independent processes that occur crucially in the cell wall instead of oxidation through anaerobic or aerobic metabolism. These all are adsorbents which can remove pesticides from wastewater. Inorganic adsorbent, zeolite. Zeolites are crystalline aluminum silicate. The formula of zeolite is Na2O, Al2O3, SiO2, H2O. These are crystalline aluminum silicate. They possess many desirable ion exchange, molecular sieving and catalytic properties which make them valuable mineral commodities. There are two types of zeolite, that are synthetic zeolite and natural zeolite. Synthetic zeolite have been used for over 25 years in commercial processes, but only recently have natural zeolite been viewed as potential valuable mineral commodities. Zeolite can be synthesized by low-cost agricultural waste like sugarcane, bagasse, rice husk, rice straw. These synthetic zeolites called low-cost adsorbent. Uses of low-cost adsorbent: solvents of low cost that are derived from natural sources, industrial byproducts and agricultural waste can be utilized with minimal processing. It may increase economical values, assist business in reducing the quantity of garbage they dispose of, and offer an activated carbon substitute. Acquiring and employing these adsorbents can support environmental sustainability and the valuation of inexpensive renewable resources. Key element in adsorptive removal of pesticide include the adsorbent doses, temperature, pH of the solution, duration and beginning pesticide concentration. There are so many advantages.
Sir, you have 1 more minute.
More.
Complete your PPT. 1 more minute. Could you please summarize?
Okay. Ma'am, last PPT or continue? I can continue.
You have 1 minute. You can summarize.
Okay. Utilizing certain low-cost adsorbents offer benefits such as utilizing plentiful and reusing currently use renewable natural resources or agricultural or industrial waste that aren't being recycled. It is crucial to remember that while several methods may be employed to eliminate pesticides, no single procedure can efficiently and economically remove every type of pesticide. This is the major disadvantage of low-cost adsorbent. Many variables, including the size of adsorbate and the function of functional group on the adsorbent and adsorbate, affect how well each pesticide is removed and the relationship. It could be decayed. Substitute the low-cost absorbent produce work just half as well, activated carbon and cost far less. The conclusion is that many unconventional low-cost absorbents that are utilized to remove pesticides from water and wastewater will be covered in this review. Adsorbent size and doses, contact time, agitation speed, temperature, pH and the ionic strength of the aqueous solution are some of the variables that affect the adsorption process. However, the ideal condition of various adsorbents can be changed. It is now more appealing to modify biomass to improve the removal capacity. These are the references from where I have taken this material. Thank you so much. Okay.
Next participant.
I can remove. Pen. Thank you, sir.
Don't sit at back, come forward please, students. This one.
May I start, ma'am? Good afternoon, everyone. I am Ankit Patel from Pandit Dindayal Energy University from Gandhinagar. I am here to present the work on non-adhesive liposomal ceftazidimine loaded nanohydrofiber scaffolds, a novel approach to accelerate the wound healing. This and along my following the entire research group, including my guide, co-guide, and their mentors and my fellow colleagues. First of all, what is the? I would like to introduce the work for what we are running behind. That is the hard to heal or the chronic wounds. As we know, there are multiple types of wounds. Either it's running types of wound from different types of degree. It's belonging from the primary, secondary, tertiary, or quaternary burning wounds, or it should be incisional, excisional, post-surgery, or it might be any bacterial infections, or particularly when we talk about the chronic wounds, it is all about the diabetic ulcers, because compared to the normal and diabetic patients, when it's come to the healing of any wound, diabetic patients takes longer time to heal the wounds. But multiple times when we dressing of any wounds, the problem is we have to dress it every day. At every day we have to dressing the wounds. Second, we have to also take preventions from the surrounding microorganism, dust particles that we are going to coming in contact during that wound. Other than that, the high dose, for example, if you are getting a wound, or if you are suffering from wound and doctor is prescribing and some antibiotics, multiple antibiotics you have to take, but the side effect will be you will get from nausea, headache. These are either it may be oral or intravenous, but you have to suffer from the side effects. But what is the strategy that we are launching is nano hi-fi, a novel product in the market, as well as the work. It's purely novel because it is composed of scaffolds we have prepared. The first of all, you have to know about there are two components. One is hydrogel and second is scaffold. the hydrogel have its own characteristics and scaffold have its own characteristics. But when we talk about the hydrogel, it is encapsulated with the liposome. Liposomes are loaded with the drugs, particularly antibiotics. Here we are talking about ceftazidime. And when we are taking antibiotics, either oral or intravenous, they are in a higher concentrations. Till it is reaching to the targeted site, the concentration gets lower. But when we talk about the dressing wound, we are directly getting contact with the dressing site or the wound site, and with the low dose concentration, we can directly target the drug delivery at the wound site. So here is the major two components as I discussed. One is hydrogel and second is scaffolds. This hydrogel has its own characteristics, that is free flowing gel, intimately covers the wound surface. And one more disadvantage, when we are dressing the wound, after dressing a brown color layer is getting form on the wound. And when the dressing wounds we are taking out, so it get attached with the dressing wound and the patient has to suffer a pain because it is stick to the wound. But the hydrogel is viscous and moisture, it makes the wound site hydrated, and that it's very smooth and it is pain relief. Basically there is no pain involved. And third, it's prevent the biofilm formations, that a brown color or a platelet formation we observe normally at the wound site. Second, the scaffolds which we are talking here, using hydrogel we are making it into the scaffolds using electrospin technology. We are making a scaffolds of less than composite of liposome less than 100 nanometer. The hydrogel is impregnant into the gas, it's fill the deeper wounds, it's capable of absorbing the exudate, because if there is a wound site, it will release some exudate, it has capability to absorb all the exudate. And the sustained drug release, when we are talking about dressing, every day we have to dress the wound, but the hydrogel, it has a liposome, it has sustainability, it will release the drug till the 72 hours, that is approximately 3 days, and which is for 3 days you don't have to dress your wound, which is the best advantage over the traditional or the conventional techniques that is available in the market. And we have some studies on the hydrogel properties using liposome and bacterial fusions, viscosity, gelation time, dissolution rate, Allen's assay and scratch assay. Here the two pictorial representation has been shown. Actually it's not a representation, it's an assay that has been performed, one with the bacterial penetrations into the media, and one a blank site, a square, where we have impregnated the scaffolds, and you have seen no bacterial penetration has been occur. It is purely compacting all the foreign particles, microorganism and dust particles getting at the wound site. When we talk about the making of nanohyphae, where we have bare antibiotics, it loaded into the liposome, we pigmented them so it can be compatible with our immune system. We make it into the hydrogel, and finally we using the what we say electrospin technology, we make it into the scaffolds, and how it's getting into the dressing site, and it's a patented technology in the 2021. And we talk about how it's work. When we getting in contact with the dust particles, bacteria or microorganism or any foreign contaminants, it is what we say protected from the nanofiber level, which is in nanometers. Then the hydrogel that has encapsulated into the liposome, as encapsulated with antibiotics in the hydrogel, they release, it gives sustained release for the 72 hours at the wound site. When we talk about its efficacy, normally the hydrogel form into the scaffolds, but when it put at the wound site, within the 10 second of time it get hydrated at the wound site, and it gives the sustained release for the 72 hours. Thank you, ma'am. Now it's last slide where we conclude with conclusions and the future perspective. Conclusions is all about the properties of the hydrogel, and the future perspective is making into scarless wound healing using bioactive compounds, personalized medicine, because every have their own different immune system. With respect to that, we can incorporate different antibiotics to make it heal, and advancement to resist multi-drug resistance bacteria and chronic wound, and smart scaffold where it can be sensile sensible to the wound site. Thank you so much.
So Ankit, it's a nice presentation.
Thank you so much, ma'am.
My question to you is, what is the source of liposome?
Ma'am, liposome is basically a lipid bilayer. There are multiple ways, multiple types, like we have soybean phosphatidylcholine.
This is what I wanted to know, like which source did you use to extract liposome?
Ma'am, it is commercially available egg
Okay.
phosphatidylcholine, or also called as alpha L phosphatidylcholine, that we use to make the liposome.
Okay. And you mentioned it's a patented technology.
Yes,
so
ma'am.
you and your team has patented it.
Yes, ma'am.
Okay, so it's a published work as well.
It is actually in 2021 it has been published as a design. Now we are working at the product level, and if we have bring it to the product, it's a patented. So we will going for the product patent.
Okay, thank you. Anyone else has to ask any question? So thank you, Ankit.
Welcome, sir.
You had?
Sure, sir. Sure. Sir, that's the best thing about this is to make it as diabetic wound, particularly the chronic wounds. Actually, all the things that we are making, it is very effectively. Most of the time, what is happened, we make the best of best novel products, but when we came it at to make it as a large scale or commercial, or making it to take at a commercial market level, then it is get difficult to the inventors to make it feasible to get their own cost out of it. But whatever the technology or the components we use with at the lab scale, it is very cost effective. But as it is into the patent process right now, but I can say it is economical, even the middle class family can afford it. But the particular price to get it, I have to revert you back by considering all the opinions from my research group, sir. Thank you so much, ma'am. Thank you everyone for this patience. Thank you everyone.
So which one is it?
This one.
Good afternoon to all. Myself, Jayaprakash Rajan. I am teaching in their MJDU campus, Pachunga University College. And today my discussion topic is the use of a waste material, that is a red mud, as a catalyst for extraction of a silica. Nowadays, silica is also important. We said their semiconductor industry, generally silica we extract from their inorganic source. There lots of energy is required. But in this case, this red mud is also free available and waste straw. We can use for economically extraction of a silica from using a red must. Here, generally, we have a disposal problem of these work sites or sludge or waste material. Generally, 50% we can use this waste material as a different purpose, Remaining we have a problem for disposal. Then this my purpose to utilize as a catalyst. There we have a environmental problems. Environmental problems means this is highly pH value, and due to high pH it's deteriorate where we are going to dispose this red mud. And there are some guidelines, but still there are leakage or there are different problems. That's why here generally cement industry they're taking red muds for some application. That is the known as a UJJ construction materials. We can extract iron, we can others means UJJ fertilizers, desulfurizations, and some red mud we can use as a polymers also. Other we can use a catalytic application, and also this red mud or oxide or waste material we can use as a iron based materials for cells. Now here, as I say, there we have only 50% utilization remaining as the waste. That's why we are going to use these worksites or waste material for a beneficiary use for as a catalyst. Generally, why we going to reformulate it? This is the we are using a soda, and due to soda they going to early leachates, and the catalytic activity they're going to fastly decrease. That's why here objective is going to reformulate it. If reformulated, the catalytic activity will going to increase. Major elements, major here as we see in the here graph, highest that is the iron, and that lowest is the magnesium in major elements, and here zirconium, chromium, that is the minor element in the composition of this red mud. Now here rice straw means rice straw is also, this is the waste materials, means objective 2 we can this waste material use for a silica. This waste straw or rice straw, that we can also use a extraction of a bioethanol. But if directly going to extract that bioethanols, due to silica, the decrease the fermentation or decrease the efficiency of production of a bioethanols. If extract silica and after then we going to extraction of a bioethanols, the increase the efficiency. That's why here this is the known this rice straw disposal problems. Traditional, what is the traditionals we going to burn or roofings, and now in the modern science we can prepare biogas by pyrolysis, bio oils, we prepare silica carbides, and this aim here isolation of a silica component. Here we have see metal concentration in the rice straw, that highest component there around 12 to 15% that silica presence in the rice straw. That's why here we were going to extract this silica. This is the objective 2, means extract the silica from that rice waste using a red mud catalyst. Material, these reformulated, we put their different weight percent of a potassium carbonate, they're going to loadings and calcinations using these raw materials. We make a chopped powders and digested with the catalyst. Here different loadings, 0.5%, 1%, 2%. There are different loadings, and using a oil bath for heatings. Here, see, two methods of extraction of a silica.
Sir, this is the last minute now. Please wrap up.
Here we have a direct, either we extract from ash or we make a liquor. If we use a liquors, they are a advantage. Advantage means we can use for pyrolysis, biooils, bioethanols. That's why this is the second option is the better comparison to we extraction of a from S. This is the, if you see the extraction efficiency, 2% here if you use, that is the highest extraction efficiency of a silica. Digestion times 3 hours is the maximums. After then they going to decrease. This is the regenerated. First red mud, if you see here, we direct use a red mud as a also catalyst, but if you modify the increase the efficiency. This is the mechanisms. Silica, like a sodiums, the silica going to replace there, and after acid treated we extract silica from. This is the optimal extraction efficiency, 92% at 150 degree centigrade. Thank you. 3 hours. 150 degree. I check at a different temperature. 150 degree, that is the maximum efficiency they're going to.
How do you make it possible at industrial level then, or the large scale level? Because maintaining 150 temperature may be difficult.
After that, we'll set in their project scales and visit their different lab. Actually, they are. I teaching their northeast, and very difficult to at their. Yes, sir. Yes. Yes. Reaction, they 92% extract there. Silica. Yes. Open nature, I have not see there in open what is the survival rate or what is that stability. I have not checked. Laboratory work, they stable, 150 we can stable that silica. Yeah.
it opening more? So wait a moment, just a moment. It's scanning actually.
Should I just copy it or?
No, no, just open it. That's it. Won't copy presentations.
Good afternoon, everyone. My name is Abhinav Nair, and the topic of my presentation is role of secretory proteins implicated in glioblastoma pathology as biomarkers for early tumor detection. So this is the outline of the presentation. Glioblastoma is an aggressive form of brain cancer. It is a cancer of the glial cells, specifically astrocyte cells. It is aggressive as well as very difficult to detect. Much of the detection takes place in later stages of the tumor genesis, and the overall survival of the patients due to detection at later stages of the tumor is roughly 12 to 18 months, on average 15 months. The treatment options that are available for glioblastoma treatment is basically surgery, surgical resection, chemotherapy, radiation therapy, as well as temozolomide, which is often used as an adjuvant as well. The issue with the treatment options available currently are primarily that resistance to these conventional treatments affect the survival rate. So even if there is surgical resection of the tumor, there is a probability that few cells may remain, which may lead to recurrence of the tumor. Additionally, if it is we're talking about chemotherapy, there may be resistance cells or cancer stem cells that may resist the treatment if we offer a drug such as temozolomide. So because of its aggressiveness of this cancer, new treatment options are required. Additionally, because the tumor is detected at a late stage, early detection is key to ensure that the patient has a better survival rate. So due to the fact that this is a tumor of the brain, accessing the brain tissue is a difficulty in and of itself, as it is protected by the skull. So any type of biopsy would require mostly a invasive option. In addition to the regular biopsy that is done, liquid biopsy is another option that is tried, because biopsies in general give you a static picture of a tumor which is constantly changing. So as and when it acquires mutations, the form and nature of the tumor changes. So a better option is liquid biopsy, wherein the proteins present in let's say the CSF, the cerebrospinal fluid, or the blood, or even urine, can be used as biomarkers for detection, which are comparatively much less invasive as compared to your regular solid biopsy. And you cannot keep on using the same material again and again for that. So in this study, we have tried to find out what are the biomarkers that are secreted. So the proteins are secreted by the tumor, which can act as a biomarker, and if a patient or an individual has high levels or low levels of that particular protein as compared to normal tissue, that will act as a biomarker for early detection. And overall, it's less invasive if we use a liquid biopsy, or let's say blood, or let's say urine. So this is a sort of a rough representation of how the cells are secreted in a GBM or a glioblastoma tumor. So they could be secreted out in the form of microvesicles or exosomes, and so on and so forth. So these cells, these proteins being secreted out of the tumor help us identify whether there is something wrong in a patient, which we can understand using a couple of methods. So we can collect the blood of this individual or the cerebrospinal fluid, CSF, wherein things like proteins are secreted out, or in other cases the cell-free DNA or RNA is used. Once we get the sample, we can use certain bioinformatic approaches where we collect data from the RNA, microRNA samples, and we find out whether the expression of a particular gene or a protein is overexpressed or underexpressed as compared to a regular normal tissue in a healthy individual. So once you have a idea of which genes are overexpressed or underexpressed using different kinds of bioinformatic approaches, one such approach is network biology or network pathway analysis, wherein we basically use bioinformatic approaches to find out which genes and proteins are differentially expressed in a healthy patient versus a tumor patient who has a cancer or is at a higher risk of having that cancer. So here what we've done is we've tried to find out certain proteins which could act as a biomarker, specifically secretory proteins, which would be secreted out of the solid tumor, would possibly be present in the CSF or the blood. So here we've used the Cancer Genome Atlas as well as the TEX, which is a genotype tissue expression databases. So the TCGA is for the samples from diseased patients, whereas the GTEX is for the normal tissue from healthy patients. And we can compare and contrast which genes are overexpressed, underexpressed between the two sets. After that, we've analyzed those expression profiles, gene expression and protein expression profiles using database, OncoDB, and GEPI, which is Gene Expression Profiling Interactive Analysis. So in the next slide, this is a list of genes and proteins basically listed which are most overexpressed in GBM. So at the bottom you can see around 7,000 entries. So we've only shown you the first 10. Out of these, some of them are secretory proteins. This is not a representation of secretory proteins. All genes could be secretory, could not be. But we are specifically looking at certain genes and proteins which are part of which would be secreted out of the cell. For instance, the third one, CHI3L, is also present. So this protein, chitinase-like protein 1, is one of the most expressed genes in glioblastoma as compared to normal brain tissue. It is basically an extracellular matrix glycoprotein and is involved in tissue remodeling. So the crucial part is, as the tumor evolves, it has a tendency to change the tissue, which would impact any treatment that we provide. So if we, let's say, as an example that I mentioned earlier, if you use a biopsy, which would be a static representation of what goes on in the cell, there you would not be able to account for the changing environment due to such proteins and such other interactions. Sorry, okay. So this is elevated in the GBM patients. So this is a representation of how much fold difference there is. The bar plot on the right or in red shows you how much of a difference there is versus the one in the black. Similarly, and this particular protein can be visualized quite easily. So you can see these two were the so here are two cell lines which are specific for glioblastoma, where this expression of this protein. So the names are different because they go by different names, but it is the same protein that I showed you before, chitinase like protein 1. So here it is specific to glioblastoma cell lines where it is overexpressed. Similarly, two other proteins we've found out as potential biomarkers is thrombospondin 1, which is again extracellular matrix glycoprotein, which is part of cell differentiation and migration. Again, it is part of plays a good role in angiogenesis, which is again indicative of a tumor. Again, you can see not as drastic, but the levels in normal tissue is very low as compared to the previous one. Last one is LAMA4 or laminin subunit alpha 4, again a glycoprotein, part of the ECM matrix, part of plays a key role in cell adhesion and migration. Important point is it's again increased levels are found in CSF, which would enable anyone to detect it much easily and much earlier. Last slide. In conclusion, basically secretory proteins can act as biomarkers for faster GBM detection. The other advantage is, given that it is less invasive as compared to a regular biopsy, the chances of people actually showing up for screening to find out whether they have the risk or not is higher. If the process is easier, let's say it's a blood test, more people are likely to get it checked. So if it is a high risk population or someone with a genetic predisposition to that tumor, it would enable a better screening approach. Early detection would also enable the patients to have a better survival rate, and also improving the window for trying out different treatment options which are best suited to them. These three would be the major potential biomarkers that we found thus far. Amongst others, some of them have been found using bioinformatic approaches, and some of them have good data from an experimental basis as well. Now further in silico analysis can help in trying to find out what pathways they are most likely to affect, which would enable us to develop better treatment options if the changes due to these proteins are quite significant. Thank you. And I would like to just finish up by saying that I want to thank Sharda School of Basic Sciences for organizing this conference, international conference, and that I want to acknowledge that this study has been funded by the DBT.
Thank you.
Thank you.
Any questions apart from sir?
So, what is the symptom of this GBM?
Sir, basically it is can be many things. At the initial stage, it could be nausea, vomiting, headaches. So these are common symptoms that go unnoticed often because they are not that severe. So generally, when the symptoms are extreme, like chronic headache or a lot of physiological changes, like as I said, continuous vomiting and stuff like that, then only patients are likely to find out that they have some kind of a disorder. At that point, it is almost late, where the doctor can actually prescribe something that will actually help their survival.
You have also checked the gene expression profile of this protein?
Yes, sir.
So, is there any epigenetic changes occur?
You said genetic?
Epigenetic changes.
Epigenetic, we have not tried for this particular one, sir. We have not tried for the epigenetic one.
So, and you have only done the in silico work, not the...
Yeah, in silico. We further try to use other bioinformatics approaches to find out how good is this as a biomarker. The final, yeah.
Okay, thank you.
Thank you. Yes.
Thank you, sir. So, I want to ask, like, for earlier the tumorous forms are in the non-cancerous form. Later they turn, like we can define tumors into two forms,
yes.
The malignant one, which is cancer, and the non-malignant one. Like you are using your proteins, which is synthesized by the cancerous cell, and they are acting as a biomarker. So at what stage these proteins are produced? Like if the cell is like non-cancerous form, because in malignant form it starts to migrating the whole body. And then we come to know that yes. It is in severe condition, which primarily happens. And that same thing, yesterday one of the guest lecture also says some pathway for identifying the cancer. So I want to ask, like, at what stage these proteins are released?
See, right now the distinction, so if we take an example of breast cancer, the stages are well defined. Glioblastoma is not as well defined. So we cannot fully say is it the earlier stages or the later stages. Just that when we find it, there is significant detection. So we have to go through a couple of things. First, the pathways that are underpinning this change. So this overexpression or underexpression, whatever is happening, is due to some effect in the mutation or the pathway. Okay. So we have to find out that. We are only at the stage where we are trying to understand which of these proteins are involved in those pathways. So we have to go further to give you a more specific answer.
Okay, so like from this we cannot define that at what stage our disease is.
No, that is the ultimate outcome.
Okay,
it is not well defined as such as of now.
Okay, thank you, sir.
Thank you.
Please give a round of applause. That was a very comprehensive presentation. Thank you, sir.
Thank you.
Next participant, ma'am.
ये नहीं है, ये नहीं है,
ये नहीं है?
It's asking me to repair it.
Should I repair it? Let's check.
ये भी नहीं है, ये भी नहीं है. No, 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 this is not mine.
It's asking to repair. What is the problem? PowerPoint couldn't it removed it?
This is
It's fine.
Just close it, otherwise.
No, this I can close. Okay,
This is mine. Okay,
yeah,
close this
I
also.
can't close this. It's for the backdrop now.
Okay, okay, okay.
I'll give you the presentable so you
Okay,
don't have
okay.
a problem.
Thank you, thank you. So good noon, everyone. My name is Dr. Arpita Tripathi. I am Assistant Professor Botany in Faculty of Education, Tirthankar Mahavir University, Muradabad. So this work is related to my PhD work, and I have done my PhD from CSIR CMAP Lucknow. So the title of my presentation is Unlocking the Potential of Endophytes for Enhancing Antimalarial Artemisinin Yield in Artemisia annua plant. So basically I am plant biologist. So before starting, just let us know what is Artemisia annua. Artemisia annua is a family Asteraceae family plant, which is most dominating family of angiosperm on the earth, commonly known as sweet wormwood or sagewood. And this plant comes in limelight in 2015 when Madam you too won Nobel Prize for the discovery of artemisinin. So artemisinin is sesquiterpene lactone sharing endoperoxide bridges. So artemisinin is found in highly effective in treating severe kind of malaria caused by multi-drug resistant Plasmodium falciparum. According to WHO report of 2024, around 263 million cases of malaria have been found under the theme accelerating the fight against malaria for a more equitable world. So WHO recommended artemisinin based combined therapies such as mefloquinone and chloroquinone for the treatment of malaria, which is caused by multi-drug resistant strains of Plasmodium falciparum. So again, the term endophytes. Endophyte is any microbial entities which can live inside plants without causing any harm to it. So this term was coined by D. Berry in 1902, and many endophytes have been reported to enhance the growth and yield of many medicinal plants, especially by modulating the expression of genes which are involved in biosynthesis of important secondary metabolite as vincristine, vinblastine, artemisinin, and so on. So many endophytes have also been reported to impart tolerance to plant against many abiotic as well as biotic stresses. So the aim of this study to identify and characterize endophytes that provide a synergistic effect on plant that would substantially enhance in planta artemisinin biosynthesis for sustainable development. So this diagram is showing the mode of entry of endophytic bacteria inside the plant. So it may be horizontal by root hairs or any wound which is found in roots, or it may enter through vertically by stomatal pores. And this picture is showing how endophyte provide benefits to plant. It can be direct mechanism or indirect mechanism, like it provide plant growth promotion, phytopathogenic controls, induce systemic tolerance to plant, and enhancing nutrient availability in planta detoxification, nitrogen fixation, phosphate solubilization, ACC deaminase production, which is related to ethylene production inside plant, phytohormone synthesis, siderophore synthesis also. So this picture, which is this is working. So this Art7 is a superhero of my study, which is Burkholderia cepacia, gram-negative bacteria. And this picture is showing the treatment of endophytes as compared to control. We found more herbage yield as well as artemisinin content. So, in general methodology, firstly we isolate and identify endophytes, and isolation was done from the different plant part of Artemisia annua itself, and then these endophytes were tested for different plant growth promoting activities such as auxin production, phosphate solubilization, siderophore production, and so on. Then after that 23 best bacteria were selected for further glasshouse as well as field experiments. So, two experiments were performed initially. First is to study the effect of isolated endophytes on growth and artemisinin content of Artemisia annua plant. And second experiment is to investigate the effect of Art7, which were found to be best from experiment number 1 in presence of various permutation and combination of endophytes. Then in result, this table shows the number of isolate which I have been isolated from different plant bloods from seeds to root, and these genes were submitted to GenBank, and these are their association number, and further has been tested for different plant growth promoting activities like phosphate solubilization, auxin production, nitrogen fixation, ACC deaminase, and siderophore production. This graph is showing the screening of endophyte which were isolated from the seeds of Artemisia plant for plant growth promotion, and we found that as compared to control, which where plants were not treated with any endophytes, the endophyte treated plant was higher in case of both plant biomass as well as in artemisinin content. So again, after that experiment, one permutation combination experiment was performed to check the synergistic relation among these endophytes, and we found that composition number 50, which is having Art1, 2 and 7 and 9 were found to be highest in case of plant biomass as well as artemisinin content and artemisinin yield. Then again, experiment were performed to check the evaluation of consortium. Consortium is basically the mixture of endophytes which is having synergistic association among them. So to check the evaluation of consortium of selected bacterial seed endophyte in enhancing artemisinin yield and mitigating the various stresses like salt, waterlogging and rot induced damage in Artemisia annua plant. And here we found that under all 4 conditions, maximum enhancement with consortia at 1, 2, 7 and 9 in treated plant as compared to control 1 in both in all 4 normal as well as drought, salt and waterlogging condition. Same as in case of artemisinin content also. So another, after many glasshouse experiments, we have performed field experiments. So for this, 2 varieties have been taken. One is Sim Arogya. Sim stand for CSIR CMAP, so Sim Arogya, and another is Sim Sanjeevani. So as compared to control, Art7 inoculated plant shows higher enhancement in dry weight as well as artemisinin content in both the varieties, both for plant biomass as well as artemisinin content. So in concluding remark, this result shows the presence of natural endophyte in plant probably play an important role in promoting plant growth and secondary metabolite production to the host plant, and again the permutation combination experiment proved their complementarity because of their synergistic effect. Microbial consortia of functionally diverse group provide a ecosystem sustainability as microbial communities can survive in a range of heterogeneous stresses condition, and this result open new vistas for the development of synthetic communities of microbes for providing benefit to a wide range of services for improving crop yield, productivity and tolerance to different environmental stresses. So in future prospect, what I have feel that there is a need to identify more novel endophyte and their host specificity, because endophytes are host specific in nature sometimes. So there is a need to identify more and more endophytes, and their mechanism of action and in under extreme environmental conditions, and their dose and frequency of endophytes inoculation specific to its host plant needs to be checked. And because in my experiment I have provided like for 15 days intervals. So thank you so much for listening.
Thank you very much, ma'am. Please give her a huge round of applause. I sense people are very hungry for lunch. Please give her a huge round of applause. The emphasis on huge.
Thank you.
Does anyone have a question? Sir?
So, you have not shown any data, as you mentioned that this molecule is enhancing the anti-malarial activity.
Anti-malarial activity. Sir,
So-
anti-malarial activity is because of artemisinin. Okay, so this is proven from various reports. So my study was focused on endophytes which were involved in biosynthesis of that particular drug artemisinin. So that's why I basically checked the effect of endophytes in upregulating the synthesis of artemisinin inside the plant only.
But you mentioned endophyte for enhancing anti-malarial activity. So,
And enhancing artemisinin yield in Artemisia nova plant. In
Okay.
title.
Thank you.
Priyanka Singh, no? Ma'am, Priyanka Singh, ma'am, please. Rishika Singh. Okay, next. Halima. Rishika, ma'am, no? Ma'am, is it on pen drive? Okay.
This is a marker.
Very good afternoon to all who are present over here. Myself Rishika, I am pursuing PhD from Agra College, Agra. And my presentation topic is a review on different methods used to synthesize zinc oxide nanoparticle, which is the green synthesis. These are my content. Now comes nanoparticle. Nanoparticles are the particles of metal with the diameter ranges to 1 to 100 nanometer in sizes and which possesses the distinctive different physiochemical properties. This prefix nano, which means dwarf, and which is the 1/1000th of the unit. Now comes zinc oxide nanoparticle. Zinc oxide is an inorganic compound with the formula ZNO. which is a white powdered and soluble in water. Nanoparticle of zinc oxide are called as zinc oxide nanoparticle, which have a diameter less than 100 nanometer. They have a large surface area which is relative in size and high catalytic activity. The exact physical and chemical property of zinc oxide nanoparticle depends on the different ways from which they are synthesized. In material science, ZNO has a wide band gap semiconductor. Now comes the methods, the different methods. The first one is the chemical synthesis and the biological synthesis method. Chemical synthesis method include a hydrothermal method, precipitation method, chemical vapor transport method, thermal evaporation, ultrasonic irradiation. And the biological synthesis method include the plant mediated synthesis, algae mediated synthesis, and the microorganism. Now comes the hydrothermal method. In this procedure, the solution of zinc salt, which are mixed with the sodium hydroxide, we can continually stirred and transferred into the autoclave, and then this aqueous solution is left to cool down, and then this is followed by precipitation, wash from this method. Now comes the precipitation method. In this method, nanoparticles are synthesized by directly precipitation method using zinc nitrate and potassium hydroxide. In this procedure, the aqueous solution of zinc nitrate and the solution of potassium hydroxide are prepared with deionized water, respectively. The potassium solution is slowly added into the zinc nitrate solution at room temperature under vigorous stirring, which result in the formation of white suspension PPT. Now this white product is first centrifuged and then rinsed with the water, and then we get the zinc oxide. Now comes the chemical vapor transport method. In this technique, zinc oxide nanoparticles are heated with the zinc powder in the presence of transport agent such as iodine or graphite. Firstly, the zinc powder is heated at the high temperature in the presence of transport agent. Now the powder is transferred to the cooler region, and then the powder condenses to form the nanoparticle. This is the ultrasound irradiation method. In this technique, which is utilized to create the nanoparticle in the solution phase operations. Now in this, we have synthesized nano zinc oxide by the ultrasonification method, taking this zinc salt which is dissolved in the sodium hydroxide in the complex. Later, this beaker is immersed into the water in the ultrasonic bath devices. Then sonification is done. Then after sonification, we have to centrifuge. In this, the supernatant is removed and the white PPT we get. Now from this white PPT, we have to wash with ethyl alcohol and with deionized water, and then we get the final zinc oxide nanoparticle. Now the thermal evaporation method. This is commonly used method. In this, a temperature of 1000 to 1100 degrees Celsius we get, and graphite is often combined with the zinc oxide nanoparticle powder, which is act as a reducing agent to create the pure zinc nanoparticle. The addition of carbon causes the zinc oxide precursor, which is to be used as a reduction agent. Now we have to formate the zinc and the from this zinc oxide nanoparticle, and then evaporation occurs using this thermal evaporation approaches. We have to create pure zinc nanoparticle. Now comes the plant mediated synthesis. In this, we have taken the tomato fruit, camelin flower, and olive leaves are first rinsed with the double distilled water and then allow it to air dry. taking this water which is and then extracted to the powder ground leaves, flower and fruits. Afterward these extract are cooled to room temperature and then filtration. This collective plant extract and the zinc oxide nanoparticle are mixed and then pour in the separate flask, and then we have mixed with the synthesis of zinc nanoparticle. Now this comes the green synthesis of nanoparticle, which is divided into two phases. That first one is plant extract, and then we have synthesized the zinc nanoparticle. In this plant extract, we have taken the plant powder which are stirred and heated at this 70 degrees Celsius in 100 ml distilled water for 30 minutes. This extract was allowed to cool at room temperature, and then the pH of the plant extract was 7.84. The extract was then filtered with Boltzmann filter paper and then stored for the experimental use. Now taking the plant extract to zinc acetate dihydrate, sodium hydroxide was added dropwise to maintain the pH. Then the mixture was continuously stirred and heated at 70 degrees Celsius for 30 minutes to complete reduction, and we get the formation of white PPT. Now this white PPT then we have collected with decantation and then washed with distilled water and oven dried at 70 degrees for overnight, and we get the nanoparticles.
So where will you be using these nanoparticles? What are the applications of those?
Ma'am, nanoparticle, applications are widely, but in this I have only shown the synthesis method.
It's a part of your PhD?
Yes, ma'am.
So where will you be using it? Application of your
Yes, ma'am. In basically in a sunscreen, low zinc nanoparticle are used, and in common ways also.
Anyone else has a question? No? Thank you, ma'am. Please give her a round of applause. Next up, we have Priyanka Singh, ma'am, please.
afternoon, everyone. My name is Priyanka Singh. I am pursuing my PhD from VIT Villa Institute of Technology under the guidance of Dr. M. Sivasankar, Department of Chemistry. So my today's session presentation is impact of plastic pollutions on agricultural soil and analyzing extracellular polymeric substances and morphological changes in microplastic with sludge amended. What is EPS? EPS, extrapolymer substances, are natural polymers secreted by microorganisms into the environment, which is a form of protective layers for the cells against the harsh environmental conditions. It is composed of polysaccharides, proteins, as well as DNA and lipids. So microplastic are a small particles smaller than 5 mm in diameters, which are insoluble, non-degradable, etc. Microplastic can affect directly or indirectly to the soil, which may be physical or chemical, porosity, microbial activity, aggregations, nutrition, and community assembles. So these are the materials and methodology I have done for my work. So we incubated microplastic, 3 different microplastics, that is polyethylene, polyvinyl chloride, and polystyrene in sludge, amended agriculture soils and agriculture soils, from which I extracted EPS, and from that extracted EPS we have estimated total carbohydrates and protein, and after 45 days of incubation of microplastic in the sludge amended agriculture soils and agricultural soils, that microplastic is extracted to see the morphological changes of the microplastic in agriculture soils and sludge amended agriculture soils. So for that purpose I have done optical image and FSM. So these are the pictures of extracted agricultural soil EPS and sludge amended agriculture soil EPS. So these are the data which we got from this is total content of EPS, in which we can easily see that agriculture soil containing polyethylene, both agriculture soil as well as sludge amended agriculture soil, EPS content is high, which is due to the more bacterial interference in polyethylene. Constituent of EPS. So this is the carbohydrate. We can easily differentiate that this is the carbohydrate is high in sludge amended agriculture soil than that of the agriculture soil. So as well as protein also is high in sludge amended agriculture soil than that of the soil. So we can say that because carbohydrate is high because of it is having high concentration of organic carbon sources, which promotes the growth of microorganisms that produce more carbohydrate. And protein is high because it shows that sludge is having high protein concentration, because microbial communities in sludge are often more diverse and active due to high nutrient availability. These are the optical images which after 45 days of incubation of microplastic in this sludge and soil, this has been extracted, which to see the morphological changes, but we exactly by optical image we cannot differentiate morphological changes. So further we went for FSM images. So we can easily see that upper one is polystyrene, second is PVC, and the third one is polyethylene. So this is control one. Control is flatted, in which we can see that in sludge agriculture soil it is being clumped and more smooth. After that, in later it is showing that it is being spherical shape, which we can say that after incubation in agriculture sludge amended agriculture soil, the microplastic is being more affected, and that more affect the soil properties as well as microplastics. So it is maybe due to the aggregations, due to the more colloidal substances present in the soil samples as well as in sludge samples, because of more organic compounds and nutrients. So in all 3 plastics, we can say that more polyethylene microplastics produce more EPS production in the soil as well as in sludge amended agriculture soil. Thank you. For carbohydrate phenol sulfuric acid method, and for protein Bradford method. Yeah.
the chairperson, the coordinators, researchers here present, my fellow students, good afternoon to you all. My name is Halima Umar Bulama. I am a PhD student from the University of Maiduguri in Nigeria. I am here at Sharda University to conduct my analytical work here and get my results, and then go back to Nigeria, to my university in Maiduguri, and complete my PhD research. So I'm working on the quality assessment of kadal, which is a fermented grain flour produced from whole and decorticated maize and millet grains. From dokla, dosa, dahi are some examples of Indian fermented foods. So fermentation is an age-old method of food processing and preservation that helps in transforming raw agricultural materials into finished products. And to achieve the UN Sustainable Development Goal number 2, which is to end hunger, improve nutrition and food security, and also the UN Sustainable Goal number 3, which is to ensure healthy lives, promote well-being for all people at all ages. People must have food and nutrition security. All right, nutrition security exists when all people at all times have physical and economic access to safe and nutritious foods that meet their health requirements and also their food preferences. So food fermentation, as there is a serious issue. There is a serious global issue with access to safe and nutritious foods. In 2022, over 1/3 of the world population, about 2.8 billion people, could not access nutritious foods. So there is a serious problem with food and nutrition in the world over. Fermentation as a method of food preservation is being hoped to use in order to improve nutritional value of foods and also ensure food and nutrition security. So I'm working with maize and millet grains. I am producing kadal flour. Kadal is a Kanuri word. Kanuri is a tribe in my state. So kadal flour means fermented grain flour. Anywhere you see kadal, it's talking about grain flour that has undergone the fermentation process. And in order to obtain the fermented grain flour, cereal grains are used. Cereals such as millet and maize grains are used. As we all know, the world over, cereal foods are consumed by so many people across the world. And people try to meet some parts of their protein requirements by consuming cereal foods. For example, we have so many vegetarians here in India. And how do they get to meet their requirements for protein? They get to achieve that by eating the plant foods. And cereal grains contribute a lot to the nutritional and energy needs of people the world over. So in this work, I produce fermented grain flour from maize and millet grains, like I earlier mentioned. So the maize and millets were divided into, I had 4 different setups. For the first setup, the maize grains were divided into 2. I had the whole grains and the decorticated grains. The whole grains means that the grains were just sorted, foreign materials, dirt, insects, and all extraneous materials were removed, and then the grains were cleaned and soaked inside water and allowed to ferment naturally. So the other portion of the maize grains were dehulled or decorticated. That means the hulls or the seed coats were removed. And then the grains were also fermented separately. The same applies to the millet grains. The millet were also divided into 2 different portions. The first portion was not dehulled. the millets were fermented with their coats or hulls. And then the second portion, the millet grains were dehulled. That means the chaff, the hulls, or the coats, however you call it, were removed before the fermentation took place. So I had 3 fermentation set up for each of the sets. The grains were further divided into 3. They were fermented for 2, 3, and 4 days separately. So after the end of each fermentation period, the grains were washed and then sun-dried on clean mats under the sun to dry. When the grains were sufficiently dried, they were milled using a local disc attrition mill, and the flour obtained was sieved in order to obtain fine flour using a 400 micrometer sieve. So the final product, curdled flour, was obtained. So curdled flour is mainly used in making a stiff porridge called tuwo in Nigeria. We mostly consume tuwo. So the flour will be mixed with water and then cooked on fire. It will be made into a stiff dough and it is eaten with soup. That is the major food we eat. Here in India, I also consume tuwo. I buy some flour in the market, wheat flour, and I make tuwo with it, and I make soup and I eat. That is what we majorly eat. So, after obtaining the flour, the quality parameters, all right, the quality parameters of the flour was assessed in terms of moisture content and also so many other parameters. So from this chart, you observe that the moisture content of the flour increased with increase in fermentation period. So the first, this is for the whole unfermented maize flour, which served as the control. And then the second chart, the second bar is for fermentation for 2 days. The third one is for fermentation for 3 days. And the fourth is fermentation for 4 days. So as the fermentation period increased, the moisture content increased. So this first chart is for the whole grains that were not dehulled, and the second is for the grains that were dehulled. The same thing applies for maize and the millet. So from this chart, we observe that there was the increase in moisture content of the flour after fermentation was higher in the maize flour compared to that of the millet flour. So next is the protein content. From the graphs, we notice that there is a decrease in protein content. As the fermentation days proceeded, the protein content decreased from the second day, third day, and fourth day of fermentation for the whole grain flour and the decorticated grain flour. Though the same thing applies to the millet, but the decrease was more pronounced in the maize curdled flours than in the millet curdled flour. Next is the ash content. The ash content also decreased as the fermentation period increased. And then we have carbohydrate content. The carbohydrate content in some aspects decreased, like in the whole maize flour. It decreased on the second day of fermentation, but subsequently increased. Likewise, for the decorticated grains, the carbohydrate content was showing an erratic behavior. It sometimes decreases and increases because of the numerous activities that were taking place during the fermentation of the grains. So in conclusion, the moisture content, protein, fat, and carbohydrate content results have been reviewed and compared with the control sample. The obtained results are within the limits as per the Food Safety and Standard Authority of India. So thank you for listening.
Thank you, Halima ma'am. Any questions? Ma'am?
Thank you, Halima. Just question, when you do the measurement like moisture content or carbohydrate or protein, how many times do you measure for each sample? Do you measure one sample only or you repeat the measurement?
It's measured twice and the average of 2 measurements are taken.
Okay, and what's the difference? So it's if you have multiple it's good to have error bars with the standard deviation to tell how do you, this is the average.
Yes.
But how different are the two results? Are they very close or far away?
Yes, some are significantly different while others are not. The results were subjected to statistical analysis of variance ANOVA.
Okay, because sometimes the difference between like 2 days and 4 days is very small.
Yes,
and we need
sometimes-
to compare that to the error in the measurement with the standard deviation, error bars, etc. So it's good to have error bars in your results so we can tell if the difference from 2 days to 4 days is significant or it's the same as within the difference between one sample and two sample on 2 days, for example.
Yes, I understand.
Okay, thank you.
Sir.
Please give a round of applause. Next up, we have Soro Anthony. I copied it. Oh God, I didn't copy or what? Where is it? I think I didn't copy your presentation yet. Wait a minute. Can you give me a moment? Is it fine? Can you give me a moment or? Yeah, I'll just give. We need to copy it directly to you.
No problem. It's already published data. Okay, very good afternoon to all the participants and the organizing committee. I am Darshan Ladwa from Pandit Deendayal Energy University, and today I am going to talk about some of the novel approach that we have selected for combating the multi-drug resistant E. coli and Klebsiella pneumonia. Like they are the specific species coming under the Enterobacteriaceae family, and we are trying to combat them in the form of like when they are affecting the wounds. So I'm doing my PhD in Pandit Deendayal Energy University under the guidance of Professor S.S. Manoran, and my co-supervisor is Dr. P.S. Pradeep. So going forward to the presentation, like I don't want to be in between the lunch and the participants. So the current strategies, whatever we have used. So some of the basic terminologies that I want to discuss is like the multi-drug resistance. Like this is the specific ability of the bacterial species is that they are resisting the several antibiotics. So what we are trying to do here is we want to use the old antibiotics. So the current hypothesis is not to go for the new antibiotics. So once we are going for new we are discovering any of the new antibiotic within the span of 1 or 2 years, again bacterial species will show the resistance. So what we are trying to do here is we are using liposomes as a nano drug carrier. So there are various vesicles are available. Likewise, we can say dendrimers, quantum dots and all. But why we are choosing liposomes over here is just because we can do the surface modification according to our requirements. And the other thing is they are quite easy to formulate. And the other thing is in this project we have gone for normal liposomes as well as the surface modification. Whatever we are talking about here, we have modified the surface of liposomes with maleimide functional group. So in the methodology part, we have used thin film hydration method for the formulation of liposomes, in which the specific molar ratio of phospholipids as well as the other materials that we can say oleic acid and cholesterol, which provides higher stability and required rigidity to the liposomes. And we have selected 6 antibiotics from 3 different classes, so which are not currently as much as efficacious right now to these strains. And we have formulated the liposomes of less than 100 nanometer particle size. So in the characterization part, I can show you, like, for all the formulations, 2 sets of formulations that we have prepared, in which one are just simple liposomes and other ones which are decorated with maleimide functional group. So all of them are giving the particle size less than 89. The highest particle size that we are getting is 89 nanometers. And the other thing is zeta potential value, which is also falling under the regular, we can say the stable form. So which shows like minus 30 to plus 30 electron volt it is there, millivolt is there. Then we can say all the formulations are stable. And the other thing is encapsulation efficiency, as we have utilized 6 antibiotics. So each and every antibiotic, in which quantity it is present inside the lipid formulation, that we try to see. And we can say the least encapsulation efficiency we got for the maleimide conjugated doxycycline formulation, and the highest encapsulation we have got in the liposomal ceftriaxone formulation. And we have also gone for the atomic force microscopy for our selected samples, that is maleimide conjugated ampicillin and piperacillin. So in that also you can see in the atomic force microscopy, like the globule formulation is there. And in the result part, we can say like we have selected 10 samples from both of the species, that is Klebsiella pneumonia as well as Escherichia coli. So in which with the help of MIC values, we have found out that 2 of the samples of each and like single sample from each of the species, they are resistive to most of the antibiotics. So you can see the data in which we have given MIC value for bare antibiotic as well as liposomal formulation, and our final maleimide conjugated formulations also, in which you can see the maleimide conjugated piperacillin and ampicillin are giving the best results, in which you can see like they are giving 64-fold decrease in the MIC values. So if at all we are going for with the bare antibiotic, instead of that we are going with liposomal formulation, we can reduce the dose as well as it will give the more activity. And further, for biocompatibility studies of our formulations, we have used the human dermal fibroblast, so which we have treated with the lower as well as higher concentration of all the formulations, which is 25 mg per ml as well as 50 mg per ml. And in all the data, you can see most of the samples of the the human dermal fibroblast, they are not getting damaged. So we can say our formulation is highly biocompatible. And in the scratch assay also, again we have used this human dermal fibroblast, and we have put one scratch and we have treated them with our selective formulations, and in which also you can see in the control, this is the time-lapse representation. So after the 24 hours for liposome, maleimide conjugated liposomal ampicillin, the wound that we have created, it is completely closed. So furthermore, from this fibroblast cell lines, we have extracted the complementary DNA, and we have gone for the gene expression analysis, in which we have selected some of the genes we are taking, playing the main role in the wound healing processes. So this is the set of primers with which the complementary DNA was amplified, and in this all the genes, we can see there is a higher fold change for all of the processes. And in the heat map also you can see that melamide conjugated ampicillin and piperacillins are giving the best results. And I have also tried to showcase the cellular network of all the processes which are taking place during the wound healing process. And in conclusion, I would like to say that instead of using bare antibiotics, if we are going for liposomal formulations, so I also try to illustrate, like if bare antibiotics are going to the cell wall, it will get rejected with somewhat kind of resistive mechanisms of the bacterial cell. But whereas if we are using our formulations, it is properly getting attached to the bacterial cell, and it is depositing the antibiotics inside the bacterial cell. So the disruption will go easily, and with lower dosage form also we can cure the wounds. And other thing is the selective ampicillin and piperacillin formulations, we are again going for the animal studies and furthermore. And I would like to say, like, this is already published recently in Nature Scientific Reports. And for acknowledgement, I would like to say thanks to Sharda University, like for organizing such an event and giving us chance to present our data. And I would also like to STARS MHRD, because this work was supported with STARS MHRD funded project. And I would like to thank our Mother Institute, Pandit Deendayal Energy University, where we have got all the facilities in Department of Chemistry as well as Department of Biotechnology. Thank you. Thanks a lot.
So Darshan, it was a nice presentation.
Yes, ma'am.
I have few questions.
Yes, ma'am.
My first question, why maleamide?
Melamide, ma'am, in bacterial cell wall, in some of the literature, we have found out, like, bacterial cell wall is also having sulfhydryl group, that is SH group. So when we are using melamide for the surface modification, it can make the covalent bond with that SH group present in the bacterial cell wall.
What is maleamide?
Melamide is a functional group.
Go back.
Yes. Here I have tried to show.
So I just wanted to note down that interaction that you are suggesting is going to take place.
Here, this is the melamide functional group. So two sets of formulations I tried, I was telling, no. So the upper part is like just the main composition, that is L-alpha phosphatidyl-choline. And oleic acid and cholesterol we are using just for the stability and required rigidity of the liposomes. But in the bottom layer you can see this is the another set, in which on the outer side you can see melamide functional group we have decorated.
No, my question is, I already knew what is maleamide, but
yes,
this maleamide is a 5-membered ring, you know.
Yes,
so my question is, where is the exact interaction?
Yes.
Because it is not going to interact with sulfur.
Yes. So just for the interaction inside this lipid bilayer, we are using this is sorry that I skipped that part. We are using pigleted other lipids. So generally melamide functional group we are using it as a linker. Sometimes when we want to add some hydrophilic groups on this liposomal surface, at that time we can use this melamide functional group. So the whole hypothesis is based on that, as we are using this melamide functional group just to decorate the surface of liposomes, it can also be attached to the bacterial cell wall with the help of that covalent bond.
Then you are using this liposomes as a drug carrier.
Yes, ma'am.
So the drugs that you are telling me were the two
ampicillin and piperacillin.
Yeah, say ampicillin.
Yes,
so
ma'am.
ampicillin, how that ampicillin is going to interact with, because now the groups which are visible outside,
yes,
they
are
maleamide groups.
Yes,
you know? So now my question is, how this maleamide
yes,
is getting interacted with?
in this thing you can see, this is not the hard structure. So in between this lipid bilayer, there are some porine channels also. So just a minute. Here you can see once it is getting fused to the bacterial cell wall, the liposomes, the whole structure is bacterial cell.
So it means.
So once it is getting fused to the cell wall, then it will get secreted inside the bacterial cell.
So they are basically acting as a bag.
Yes, ma'am. So it is not like chemical bond formation is not there in between the liposome and the antibiotics.
So they are just sacs
Carrying
antibiotics
yes,
inside.
Yes, ma'am.
Okay. Okay. Thank you. Nice.
No.
Nice work.
Thank you. Thanks a lot.
Ma'am, I want to add that question for further this.
Yes.
Ma'am, actually, whatever structure you are saying, it is basically having a head form as well as tail form. So it is giving a missiles type of concept.
Yes.
Where your head is getting attached to the lipid layer.
Yes.
So it is attractor. Same happens with our detergent
Yes.
also.
Yes.
So, like if you are carrying your moiety inside, you are saying that you are carrying your main moiety and you are using liposomes as a carrier.
Yes.
So, like when it is getting attached with the lipophilic layer, bacteria consist of lipids and all everything. Then how your, like ma'am said, like how your moiety is getting interacted with the base, because it will, like if it is, what is the solubility of your moiety, like main moiety drug? Yes, ma'am. That's what I am. Because I am also working on same. I also presented my work yesterday, so I'm working on the same concept. Like foam, being used as a separating agent for oil.
Yes.
So I'm using that same concept that I'm using, modifying my foam for acting as a oleophilic and hydrophobic.
Yes.
So same concepts come over here. So how it is interacting, that I'm not getting.
So like you are telling, as it is hydrophobic in nature. So
the tail portion will be hydrophilic.
No, tail will be hydrophobic.
Yes.
Yes.
No, ma'am. In missiles formation, tail interacts with water and the head portion interacts with
See,
lipid.
here the thing is that it is this part is epiphilic, we can say.
Okay.
Because the head is hydrophilic, tail is hydrophobic.
Okay.
So once we are in this process, see here what we are doing is we are diluting all the constituents in organic solvent.
Okay.
So once it is getting turned into thin film,
then
we are going for the rehydration. So in the rehydration time, we are solubilizing our drugs inside the phosphate buffer. As liposomes are pH sensitive, so what we are doing is we are rehydrating this film with the phosphate buffer. So at this part, this lipid bilayers which are deposited on the inner side of RBF, it will get broke down. So just because of this the hydrophobic nature of this tails, it will get encapsulated.
Okay.
So the head are having hydrophilic nature. So by that time the antibiotic will also get encapsulated inside the hose. Hydrophilic hose will be there inside the globe.
Okay.
So antibiotic will be there inside. And outside we are doing this surface modification. So on the outside, this another part is also there, that is polyethylene glycol. So it is also giving hydrophilic nature to the whole molecule. So that is how it will induce the interaction of this one, the whole molecule with the bacterial cell wall.
Thank you.
No problem. Thank you, ma'am. Thanks a lot.
Good afternoon. Permit me to stand on existing protocols. I'm Soro Anthony Seimukumo, a PhD intent student from the River State University in Nigeria. I'm here to present a work which was done by me during my master's program at the University of Leicester and is unpublished. The desire for this work, I would say, started about 16 years ago. The cursor is not moving. It started in about 16 years ago, where on the 31st of March 2002, my wife gave birth to a wonderful daughter that brought joy to my family. But 4 days later, the situation changed. I came back to the hospital because she had cesarean operation. I came back and I was told that my daughter has been moved to the special intensive care unit for children. And I inquired, and there were no answers coming up. The only thing I was told was go and run one test after the other. And I said in my mind, I said, I hope I'll be able to quench this anxiety I'm exhibiting right now among parents and their relatives. So on the in the year 2020, in year 2019 precisely, I was given a project. And when I saw the topic, I marveled. I said, such that my wish has come to pass, that I'm working on what I desired always to find a solution. And what's this issue I am talking about? We're talking about Crigonigia. Crigonigia is a rare liver disease which was first discovered in the year 1952 by Cryle and Niger. It's a genetic disorder which affects children as a result of parents being carriers, either both parents or just one single parent, being carriers of the disease. It's not moving. Sorry, it's not moving. Where both parents or just one parent being carriers of the disease. It is estimated that 4 out of the slide, please. 4 out of 1 million persons have the Crigonigia disease or syndrome. Okay. Where's previous?
This one next.
This previous, okay. So as we can see, the disease has the acronym CNS. And they have 2 types. We have the CNS1 and we have the CNS2. In the CNS1, we have the absence of the enzyme response, which is called UGT, which is responsible for the breaking down of the bilirubin from the unconjugated to the conjugated state. Then for the CN2, we have the partial presence of the enzyme. And it is known that if not quickly detected, it could result in brain damage for the child after about 14 days of exposure, and it could result to the final termination of the child's life after about 1 month of untreatment. There you could see the genetics will tell us more. You'll see that the parent with the blue is the carrier itself. It has the disease itself. The other one is a normal person. In Nigeria, we have a law that states that we are expected to have 4 children. So if you take the Nigeria scenario, for example, for every 1 infected parent, there's a tendency you produce 2 infected children. And that has been a great concern. And for the purpose of this, we carried out a test to examine how this disease could actually be easily detected with the aid of 6 peptides. The peptides had several amino acid sequences ranging from 18 to 30, and we had 2 categories of functional monomers. We had the 8 functional monomers, and we also had 25 universally known functional monomers. What we did was, we did a simulation. That's a computational design, minimizing the monomers and also minimizing the peptides. And we created the visual libraries and also ensured that those are the peptides, those are the 25 universally known functional monomers. So after this, we carried out the results, we carried out the tests, and we had various results for the 8 functional monomers forming leapfrog components with the monomers, and we also had the same being repeated for the 25 monomers. At the end of the results, we observed that 1 of the monomers among the 8 monomers that were introduced had significant binding scores when compared with other members of his group and also the 25 other universally known monomers. And our recommendation was simple. We recommended that further work should be done on the monomers and to see how it could also be used subsequently in the production and synthesis of the molecularly implanted polymer that is needed for the detection of the drugs. I want to appreciate each and every one of us for listening. Particularly, I want to express my appreciation to TED Fund for the opportunity it has given to me, not just for running my master's, but also giving me the privilege to be part of those that were selected to be at Sharda University, which to me is a home for me, which is, to me is a place, a destination place for every intellectual to be here. I also want to appreciate those at CIF, the Central Instruments Facility, for their support and their encouragement. I believe that next time, even when more opportunities will be provided, I'll be able to present my actual PhD research work, which is on xenobiotic levels in farm produce and so on. Thanks and God bless.
Thank you, sir, for that wonderful presentation. Last but the best. Let's go. Anyone have any questions?
So, this disease that you are saying, so basically you are finding the cause for this disease.
No, what we're trying to do is, the disease is there. The disease is there. It's a rare liver disease. For some of us, for the mothers, they will tell you your child has jaundice. That's what they tell you. But there are various categories, like I said, where you have the enzyme not available at all. there are two stages, the Crigler-Najjar disease. You have the 1 and the 2. So the early detection is what is important. So we're trying to develop a molecular implanted polymer that could detect the disease at that early stage.
Thank you so much.
Yeah.
So shall I conclude the session? Please come down. Come down.
Okay.
Okay.
I'm grateful.
So I think, yeah. So already we have very less participants sitting here, but let me conclude this session. So we had 15 talks in this session, encompassing very diverse areas, and 3 couldn't come, but yes, 4 couldn't come. So 11 oral presentations were there. They were really commendable. So I think all the best for all of you who are here and they are doing their PhDs. So I wish you all the success. Hope any one of you would be getting award in the next award ceremony. Thank you. Okay.
Thank you, ma'am, for that wonderful conclusion. We had Dr. Geeta Durga, ma'am. Please give ma'am a huge round of applause. Certificate is. Thank you, everyone. We now break for lunch. Please report back to the auditorium for valedictory at 3 p.m. Okay? Thank you.
So very good afternoon, everyone. Greetings to Honorable Vice Chancellor, Sharda University, Professor Siba Ramkhara, Chief Guest of the conference, Professor Ahmed Abdullah, Dean SSBSR, Professor S.K. Banerjee, Organizing Chair and Emeritus Professor, Professor N.B. Singh, Head Department of Chemistry and Biochemistry, Dr. Anupam Agarwal, esteemed guests, deans, HODs of various departments, senior professors, faculty members, and dear participants. I, Dr. Richa Tomar, Assistant Professor from School of Basic Sciences and Research, welcome you all to the valedictory session of 2 days International Conference on Cutting Edge Science for Sustainable Development 2024. It is a moment of pride and joy as we gather for the closing ceremony of this event. Let us take a moment to appreciate how far we have come. This is not just the end of the program. It is the beginning of applying what we have learned and creating a meaningful impact in our journeys. I request Professor Khara, Professor Bhuvnesh, Professor Ahmed Abdullah, Professor Venkateshu, Professor S.K. Banerjee, and Dr. Anupam Agarwal to come over the stage. Please, sir. I'm extremely sorry. I request Professor N.B. Singh, sir, to please come over the stage. Please, sir, please have a seat, sir. Now I request Dean SSBSR, Professor Banerjee, to welcome our Honorable Vice Chancellor, sir, by presenting the bouquet and shawl. Please, we can have a huge round of applause. It's our honor, sir. So you all can join for the. बेटा पीछे थोड़ा सा पीछे जाओ शॉल भी दे सर शॉल भी है
You want to give me shawl also?
Yes, sir.
Speak winters.
We can have a huge round of applause, please. Thank you, sir. The International Conference on Cutting Edge Science for Sustainable Development, organized by Department of Chemistry and Biochemistry at the Sharda School of Basic Sciences and Research, has been a remarkable event showcasing innovation and collaboration in science for sustainability. Over 2 days, participants from diverse fields gathered to explore topics such as green chemistry, nanotechnology, bioenergy, renewable energy, big data, and biomedical innovations. Keynote talk by Professor Ahmed Abdullah on high-performance membranes for sustainable air cooling was very technical and insightful. The plenary talk by Professor Mohanty stressed upon minimal use of single-use plastics and conversion of biomass into bioeconomy was very engaging. Another keynote talk by Professor Martin focused on a holistic vision for sustainable nanotechnology was amazing. And we have heard 6 invited talks in these 2 days from esteemed experts, Professor Taqir Ahmed, Professor Saurabh Raghuvanshi, Professor R.N. Sharan, Professor P. Venkateshu, and Dr. Vipul Sarkar, invited from different corners of the country, highlighted critical issues and breakthroughs, while technical sessions offered a platform for researchers to present their findings across oral and poster presentations. So in these 2 days, we have a total of 65 posters and 67 oral presentations, which were heard by the experts. This event also fostered engaging discussions, collaborations, and the exchange of ideas that will significantly contribute to the Sustainable Development Goals. The valedictory session is a moment to celebrate the success of the conference, honor outstanding contributions, and commit to advancing the frontiers of sustainable science together. As we near to the conclusion of this enlightening conference, it's time to hear from the voices that truly embody the future of sustainable development, that is our students, our participants. Their perspectives, reflections, and experiences throughout the journey are invaluable. So I request, from my side, I invite Mr. Ravish from IIT Delhi to express his views, how he find the conference. So let us give him a big, huge round of applause as he takes over the stage. Okay, as you are comfortable.
So good afternoon all. Myself Ravish. I'm a final year PhD student from IIT Delhi. So first I would like to thank and express my sincere gratitude and appreciation to the university for hosting such a wonderful conference. It was really a nice experience to me. During my PhD tenure, I have attended many conferences in India as well as abroad also. So I'm just recollecting my past memory. So in last year, in similar time, I had attended a conference in Amity University where the Professor Pramod Kumar Singh sir has given a session. I still remember. So he has shown the highlights of Sharda University, what is the commitment of the university towards research and innovation. So these past 2 days have been a testament to that statement, because I have witnessed the presentation of many PhD students of Sharda University. To be frank, it is at par with top IIT work. So I really appreciate that thing. So I made a lot of friends among the PhD scholars also. So it was really a nice experience. And regarding the keynote sessions also, they are truly exceptional. And I got a lot of new ideas to explore further in my after post-PhD journey also. So thank you so much for this wonderful conference and enriching experience. Thank you.
Thank you, Ravish. Thank you so much for these heartwarming words. We appreciate. So I would like to take the experience from Badia. Is she here? Okay. Do we have Dr. Tara Kashav here? Please welcome her with a huge round of applause.
Thanks to the organizers to provide me an opportunity to be part of international conference on cutting edge science for sustainable development. And it's a current topic and the need of the hour for a better future. And I am, delightful and privileged to be part of it. We all witnessed 2 days full of thought-provoking and transformative ideas and conglomerate of different talks we listened to, as ma'am listed just now. All the sessions were insightful and knowledgeable. It all resonates very well that माँ सरस्वती की कृपा से मनुष्य और सभी जीवों में बुद्धि और विवेक का संचार होता है. And may the blessings of Goddess Saraswati fill our life with knowledge and wisdom and creativity. Congratulations to the organizing team, especially Dr. Anupam Agarwal for keen efforts to make it a grand success and generating new ideas, new connections, collaborations for a better world. Please have a round of applause for the organizing team. Thank you. Thanks a lot.
Thank you, Dr. Tara. So from the audience and from our participants, if anybody want to come willingly, can come and express their feelings, their viewpoint about the 2 days conference. highest minor. Give to ma'am.
प्रणाम।
प्रणाम।
अंत नहीं है, ये केवल एक शाश्वत अनवरत धारा का प्रारंभ है। ये ज्ञान, ये विज्ञान कहीं और से नहीं आया है, अनंत प्राचीन युगों के वेदों से, जो हमने इस परंपरागत युग में कहीं सिंचित रखा था, किंतु खो गया था समय के इस काल चक्र में, जो घूमते घूमते कहीं और पहुंचा। किंतु आज, अब, इस क्षण हम पुनः करते हैं प्रतीक्षा कि उस प्राचीन ज्ञान, विज्ञान, चिकित्सा, अनुभव, अनंतकालीन विज्ञान को हम पुनः निकाल रहे हैं उस संचित धारा से, जो अपनी ही थी किंतु हमने खो दी थी। Thank you so much, everyone.
Wonderful. Ma'am, can I request you to introduce yourself, please? Can I request you to introduce yourself?
Sure. Myself, Kausar Fatima, and I am working as an assistant professor in field of bioinformatics and biology in B.S. Anangpuria College of Engineering and Management, Faridabad, and I am doing PhD from Galgotia University, Greater Noida. And the reason of my participation here was totally my supervisor, Dr. Anuradha Singh, and she is a fabulous and remarkable advisor, supervisor, God, we can say. And Anuradha ma'am is not here, but my heartful gratitude to Dr. Anuradha Singh from Galgotia University. Thank you.
Thank you, Madam Kausar. Thank you for your kind words. Beautiful. Sir, give to the students, they want to express. Yeah. We want genuine feelings. People can express what you felt in these 2 days.
Very good afternoon to all the respected members. I am Indresh Singh and I came here to visit Sharda University for the first time. I am pursuing my PhD under Dr. Kailash Ramakrishna sir from VIT University, Vellore. And I would like to say that it was an extremely knowledgeable session for me, because I am attending, this is my second conference during my PhD pursuing journey. Firstly, I attended SRM, and secondly, this one is Sharda University. So like the keynote lectures were exceptionally knowledgeable. I learned a lot from there, and some of the poster presentation was also. The accommodation, the staff, then even the committee members as well as the students were very accommodative to us. So I sincerely pay my heartiest gratitude to you all. And the food and everything was very good, sir.
Thank you,
Thank you,
Mr. Singh. Thank you for your kind words. We appreciate.
All right, I am Jugana Zaharuddin Ali from Sharda University Department of Chemistry. So I think this is my first time to attend international conference. So it is very amazing to see how the event was well organized. So I hope that my fellow Africans, when we get back to our country, we will be able to organize something like this so that we can sit down together to look at our problem, so that we can have zero emission as our goal by the 2050. I hope all the things that we have had, we are going to put it into practice. May God enable us to do that, inshallah. Thank you very much.
Very good. Thank you, Jogana. Thank you for your words. There.
Okay. Hello, everyone. My name is Kabiru Jelani. I'm originally from Africa, Nigeria. Actually, it was an amazing experience, and I can also say this is my first time also to attend an international conference and to navigate within this cutting-edge institute, and also well-experienced faculties and researchers. Actually, what I will say, I'm very thankful and grateful to the organizers and also to our dear respective faculties members and mentors, researchers, and also my dear colleagues. I wish you amazing and also prosperous and future in your future endeavor. Thank you very much.
Thank you, Kabir. Thank you so much. So, Okay, we take the last feedback.
Hello.
Yes.
Myself, Dr. Vishwas Sharma, and I am from Prayagraj. 16 students of my institute are over here.
Oh, that's
So-
wonderful. Thank you for joining us.
So I will tell you few words what Sharda is. So I will connect with. Yesterday, whole day I spent over here, and in the evening, I took these students to the Akshardham, where we saw a show, a water show. So it was in a water show, I recognized, I felt that they blown laser show, laser, water, and fire. Okay, and we were mesmerized seeing that.
Evening
In a
fountain
same way, Sharda University, this conference has blown a fire in water.
Oh, wonderful. Thank you for your appreciating words.
It was an amalgamation of everything. It was it's an enormous. It was a really nice experience for me, because not only I became a student over here for last 2 days. Everything was good, from the food, from the infrastructure, and last but not the least, the behavior of each and every staff. Even the dean sir sitting over here, he's so generous. He's so generous. I mean, this is what we all have to learn. If you are on a higher position, you should be generous. This is what we have learned from this place. Thank you very much.
Thank you, sir. Thank you for your kind words. Okay, so my heartfelt thanks to each and everyone for expressing the feedback, and your words and appreciations value a lot. Okay, you also want to say something? Okay.
I'll say good afternoon, everyone. For me, I'm delighted because it's just 1 month of me being in Sharda. And I know when I came to the Dean of Research Office, the HOD said, I hope these PhD research intern students will be able to participate in the conference, international conference. For me, I'm delighted because I'm moved as an head of department in my institution, knowing that a department, not just a school, a department will organize an international conference of this capacity. I think we need to commend them. And like my colleague said, we'll go back home and put things in perspective. We believe that we'll be able to collaborate. I've always used that word with Sharda University because I am from two institutions. My institution where I'm doing my PhD and where I'm working, the Isaac Jasper Borough College of Education. So we believe that we'll be able to do some synergies and also do synergies with all the institutions here, because we know that the sky is just our springboard. And we believe that Sharda will go places. Thank you for this unique opportunity. Thank you.
Thank you. Even we are also delighted to have you here and hear you. So thank you for your words and appreciation. And we'll work further on the betterment of all this. Thank you, everyone. So now as we come to the culmination of this remarkable conference, it is only fitting that we hear from our visionary leader who has been a guiding force behind our institution's commitment to innovation and sustainability. It is my privilege to invite our esteemed Vice Chancellor, Professor Khara, to share a few words of wisdom and inspire us as we move forward with the insights. Please, sir.
Thank you, Richa ji. All the dignitaries on the dais, the HOD Anupam Agarwal, the Dean Samal Kumar Banerjee, Dr. Bhuvnesh, Dean Research of Southern University, Amar K. Mahanti ji, University of Guelph, Ontario, Ahmed Abdallah, I have already met you, Professor N.B. Singh, and all other distinguished guests, HOD, deans, faculty members, research scholars, ladies and gentlemen. When Dr. Anupam proposed the conference on emerging the cutting edge science on for sustainable development. I was very much impressed by that conference title, that the first time this type of conference is purely focusing on sustainable development. I'll declare here that one more conference will be organized, the Emerging Science and Technology for Sustainable Development Goal, in the month of June last week. A website is already launched, and we have tied up with Springer as well as IEEE, and papers will be from all the domains. Hardly anything will be left, because now we have to do the research, multidisciplinary, cross-cutting, cross-disciplinary research, and everything is science and everything is technology. So that conference will be organized in the month of June, and EST SD 2025, the website is there, people can see that. And the UN has already defined 17 sustainable development goals, and Sharda University is working in very ground level to address few sustainable development goals very seriously. And although a few of the very top-notch sustainable development goals the UN is specifying, although they have made the target that some kind of goals to be achieved by 2030. But to achieve that goals, only technology, the science, and whatever knowledge we have gained, that is to be applied appropriately. Then only we can move towards more human-centric and more green and very happy Earth or planet or global. India is very much very front leader in giving message to the world that it's that one earth, one future, one earth, one family, and one future, and that has become a very important point and thought India has put in G20 summit recently held. So, but as we move and gather the knowledge and educations and develop the technology, a lot of appliances, to my personal belief, I think that there is a thin layer, border between satisfying the needs and ambitions and then satisfying the social needs. So sometimes or most of the times now we have to be very serious that whatever we establish, it's not for gathering the money or wealth or only mere the economic growth. Alongside the economic growth, we need to ensure some of the environmental growth, societal growth, and overall development of the community, society as a whole. Still, the world is not 100% attained the literacy rate. So you know that top 3, the important sustainable development goal is education, and then your green practices, that is your energy and your hunger. Being so much developed country in this world where almost 7 or 8 billion people, but food is available on this planet is sufficient for 4 times people on this planet. India specifically has food requirement 4 times than the required food India needs. But still the equal distributions and then availability of these resources to the common people is a challenge. Everywhere you will see there are still people suffering from hunger, and the literacy rate specifically in Asia and African zone is very, very alarming. India, it is 77%, and gross enrollment ratio now we have reached only 28%. So you can understand that the dropout rate or people are not educated, and those who are educated, the skill is another problem. So all these sustainable development goals the UN has described. Now we have to put, and we have to put the knowledge and develop the science-oriented solutions to give services across, so that we move together. Otherwise, in this current scenario, if you take the last sustainable goal, the networking and collaborations and relation, but you can see the global scenario, what is happening, and if that relationship or networking or collaborations within the community, within the country, within the among the continental countries, and in this lot of problems. Still war is going on, fighting is going on, terrorism is there, peace is hampered. So world is suffering from a lot of global challenges. So that's why UN has rightfully taken all those sustainable development goals, and we are making one such to make more awareness on the sustainable goals. We are making some arrangement to remind that sustainable goals is to be taken very seriously, all these aspects, and to be implemented. Anyway, many more points are there to tell, but I think there is a time paucity. So I heard that number of papers received in this conference use and acceptance rate is very low, and you have maintained the quality of the paper, and paper has been accepted from all over the globe and India, and is a grand success. So thank you very much for organizing such a great conference in Sharda University, and I wish all the participants and very happy trip back to your native place. And this is the winter season, very enjoyable weather here, and you can see some of the places those you have not visited, Delhi, and you can visit Taj Mahal and some other historical areas in Delhi also. And if any help is required, you can contact Dr. Anupamji. Thank you very much.
Thank you, sir, for your inspiring words and for sharing your vision with us. Your guidance and support continues to motivate us to strive for excellence and innovation in all our endeavors. Thank you, sir. So now it's time to announce the results. For announcing the results, I would like to call upon Founder HOD, Department of Chemistry and Biochemistry, Professor Geeta Durga.
Thanks for the nice title. Really, it gives me goosebumps when I am here to announce the results of the winners in this international conference. Because really, when in 2013 this school was established, this is pretty new school, and when in 2013 this school was built and when this responsibility of department was given to me, then I was really never dreaming that this big we could go. But again, this is middle of the journey, we have to go long way. So our successor HODs would surely lead this department to the highest of the level. Thank you so much for coming here. Now it's the time to announce the results. So I'll be announcing the results for the poster competition.
So I request VC
Okay,
sir
okay, carry on.
To do the honor. You please announce the name.
Okay,
and
okay.
naam.
Yeah, so there are 3 different categories. So we have categorized the posters into UG PG group, then research scholar group, and faculty and postdoc groups. So I'll be starting with the junior most, that is UG PG, and I'll be starting from the 3rd position. Okay, so poster competition UG PG category. So the 3rd prize goes to Eris.
Come, quickly.
Quickly, please be quick. All the dignitaries are standing because
Sharda University.
She's from Sharda University.
Come quickly.
And the 2nd prize goes to Gaurav. from Sharda itself. And finally, the first prize goes to Shivam from MET University. Is it
Shivam
or
from
Shivani?
MET University.
हाँ, शिवराम है.
Shivram from MET University.
Just check it is written Shivam, please. Okay, please come. P14.
उधर से भी आ सकते हो आप. इधर से आ जाओ, इधर से आ जाओ. जहाँ से ठीक लगे.
हाँ, it's better. I'll call the poster numbers also. Yeah. है ना? Fine. So yeah, next is the category of research scholars, and the third prize goes to Falguni. She's from Bennett University, P20.
Falguni from Bennett University.
Okay. So it's a group. Okay, fine.
Okay, no problem, Simran. You can have it.
So congratulations, Simran. Yeah. Then the second prize goes to Aditi from Shivnada University, P8. So our heartfelt congratulations to Aditi. And the first prize, come fast. And the first prize goes to Kajal, P61. P61.
She's excited. She's not believing.
So in the last category, that is faculty and postdoc, we have 2 prizes only. And the second prize is to Sunil Kumar Pandey, P8. Has he left? Okay. And the first prize goes to Jogender Singh. He has also left? No, affiliation is not. Yeah, it's KR Mangalam University.
Okay, they are not here. We can move to next category.
Huh? No, in the poster competition, that is all. So I am starting with the oral talk. Again, the order is same. I'll be calling UG PG first. And the third prize goes to Rukaiya from Sharda University.
Rukaiya.
And the second prize goes to Abu Bakar Suraja Ibrahim.
Oh.
And the first prize goes to Soumyadeep Chakraborty. Moving forward to the next category, that is category of research scholars, and the third prize goes to Darshan Ladwa. I really loved your presentation. And the second prize goes to Bindu Yadav. She's not here. Is she here? Even her presentation was really very good. I was in the audience. And the first prize goes to Ankit Bhai Arun Bhai Patel.
We can have a huge round of applause, please.
Yeah, so moving to the last category, faculty members. The third prize goes to Dr. Tara Keshav.
Dr. Tara.
And the second prize goes to Dr. Ravish G.
Dr. Ravish.
Acha, faculty or postdoc it was, no? So please come.
Dr. Ravish from IIT Delhi.
And finally, the first prize, it goes to Dr. Subrata Chakraborty.
We can have a huge round of applause.
So thank you so much, Dr. Richa, for giving me this opportunity.
Thank you, ma'am. And I request the dignitaries to please have seat. Thank you so much. So, congratulations to all the prize winners for your outstanding achievements. You are the torch bearers of innovation and excellence, and we are proud to honor your success. Now, I'd like to call upon the head Department of Chemistry and Biochemistry and the convener of this conference, Dr. Anupam Agarwal, to deliver the vote of thanks. Please, ma'am.
Thank you so much, Dr. Richa, for setting the tone of the conference these 2 days. So respected Professor Sibaram Khara sir, Vice Chancellor Sharda University, Professor Ahmed Abdallah, Hamad Khalifa University, Doha, Qatar, Professor Bhuvnesh Kumar, Dean Research, Professor N.B. Singh sir, Professor Emeritus, Professor Shamal Kumar Banerjee, Dean, SSPSR, Professor P. Venkateshu from Delhi University, distinguished colleagues, invited speakers, dear participants, very good afternoon to all. It is my privilege and honor to stand before you to propose the vote of thanks on this remarkable occasion. To begin with, let me express my profound gratitude to the Almighty God, whose abundant blessings have made International Conference on Cutting-Edge Science for Sustainable Development a resounding success. My sincere thanks to Sri P.K. Gupta ji, Chancellor Sharda University, Sri Y.K. Gupta ji, Pro-Chancellor Sharda University for their support in organizing this conference. At the very outset, I extend my heartfelt gratitude to Professor Sibaram Khara sir, Vice Chancellor Sharda University, for his visionary leadership, generous support and encouragement to organize this conference. Despite of his demanding commitments, he has honored us with his presence. His involvement in scientific deliberation reflects his dedication to nurturing future generations. I also extend my sincere thanks to Pro Vice Chancellor, Professor Parmanand sir, for promoting research-based learning and his support to organize the conference. A special note of gratitude to Professor Amar K. Mohanty, University of Guelph, Canada, and Professor Ahmed Abdallah Hamad bin Khalifa, University Doha, Qatar, for graciously accepting our invitation and delivering their insightful plenary and keynote address. Your august presence and expertise in your field have truly elevated this event. My heartfelt gratitude to our virtual keynote speakers, Professor Martin Desimone, University de Buenos Aires, Argentina, Professor Madhumita Ray from University of Western Ontario, Canada, for joining us online and share their expertise with us. I'm grateful to all the invited speakers, Professor Taqir Ahmed from Jamia Millia Islamia, Professor Saurav Raghuvanshi from Delhi University, Professor R.N. Saran, Director, Scientific and Biomedical Consultancy, Gurgaon, Professor P. Venkateshu, University of Delhi, Professor Bipul Sarkar, Senior Scientist, CSIR, Dehradun, for sharing their thoughts to apply scientific knowledge for sustainable development. I also extend my sincere thanks to all the technical session chair for sparing their valuable time to listen the ideas of participants during oral and poster session and share their expert comments. I convey my deepest gratitude to Director General Council of Scientific and Industrial Research for sanctioning the grant for organizing this conference. I also acknowledge the generous support of sponsors, Farmanja Herbal Private Limited, Sarah Deco India Private Limited, RD Food and Products, Mr. Lakshman Prasad, VCA Healthcare, whose contribution made this conference possible. Their commitment to fostering sustainable development through cutting-edge science has been instrumental in the success of this conference. I am truly grateful to Prof. Bhuvnesh Kumar, Dean Research, Sharda University, for his constant encouragement and guidance to organize this conference. I offer my earnest gratitude to Professor Shyamal Kumar Banerjee, Dean of Sharda School of Basic Sciences and Research, for his careful observation and encouragement during the planning of this conference. I am thankful to Professor N.B. Singh sir for his blessings, guidance, enriched with vast experience for the success of ICC SSD 2024. I also extend my warm gratitude to Professor Gita Durga, Professor Vinay Kumar Verma, Professor Madhumita Ray, and Professor Manjushri Mohanty from University of Guelph, Deans and HODs of various schools and departments of Sharda University, for their valuable support in organizing this conference. My heartfelt thanks to organizing secretaries of the conference, Dr. Shivani Priya and Dr. Akhilesh Kushwaha, for their tireless effort from the beginning to organize this conference. I extend my sincere thanks to all the faculty members, support staffs, students of Department of Chemistry and Biochemistry for outstanding team spirit and successful execution of the conference. This is a testament to your passion and commitment towards excellence. My sincere appreciation to website team, IT team, Mr. Amit Verma, Mr. Imran, Mr. Ravinder, Mr. Lakshman, media team, store team, Mr. Parvat, Mr. Rohit, Mr. Rajneesh, Mr. Sonu, design team, Mr. Akash Tomar, food team, Mr. Ankit and his team member for managing the conference-related activity. I am thankful to the security people also. Lastly, but no means least, I wish to acknowledge the sheer talent and dedication of our performers of cultural event to brought life and energy to this conference. You are the heart and soul of this event, and your efforts have been nothing short of extraordinary. A special mention goes to all participants who have joined us from different states, countries, and presented their research during this conference. I am thankful for your active participation, engagement, and for bringing your enthusiasm and curiosity to this conference. Your presence and participation are what drive the success of this event, and we hope you have found it to be very rewarding experience. In conclusion, I extend my deepest gratitude to everyone, those who have directly or indirectly contributed to making this conference a magnificent success. Your efforts, big or small, have been instrumental, and for that I am truly grateful. May God's blessings continue to guide us all. Thank you and have a wonderful evening ahead. As we conclude, let us carry forward the knowledge, connection, and inspiration we have gained here. Together, we can continue to make strides towards our shared goals and create a bigger future. Thank you once again, and we look forward to welcoming you to the future conference which Sir has announced. Thank you very much. Jai Hind.
I request you all to please stand up for national anthem. भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंग विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंग तब शुभ नामे जागे तब शुभ आशीष मांगे गाए तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे. I request all the participants, prize winners and judges to come forward for a group photograph.